What listens when the world falls quiet? It was not a question of geography, it was a question of attention. There are places where attention is habit, ritual, a clockwork duty that outlasts the day. One such place was the orbital outpost designated ISS SEX, an extension of the International Space Station that had been converted, incrementally and improvisationally, into a laboratory of long watches and patient sensors. On the face of remote duty, it was indistinguishable from all the other nights. Scheduled systems checks, curated playlists of low-frequency telemetry, the soft loop of recorded announcements reminding that night had the same surface of ordinariness. The artificial circadian lights dimmed according to a schedule devised to trick human biorhythms into compliance. Fans whispered their indifferent rotations, pumps hummed, valves clicked with bureaucratic certitude, and the feedback lights of monitoring panels traced the same slow choreography they had traced for months. In routines like these, it is not dramatic gestures, but the fidelity of small things that keeps the machine alive. A tabular readout that must not freeze, a thermal regulator given an extra minute's patience, a log entry penned precisely at AO2. From the vantage of an objective observer, that night might have looked like any other exercise in controlled monotony. Yet within monotony, there is a threshold where attention sharpens, not with the drum of cortisol, but with a small, acute readiness. The watchmen of the outpost had learned to respect that readiness. They learned to treat anomaly not as a drama to be solved on impulse, but as a text to be unrolled slowly, with the precision of those who have seen false alarms and harmless coincidences masquerade as portent. The first sign was not a voice and not a flare. It was a digit on a console that should have been nothing, a patterned increment in a spectrum monitor's count. The radio receiver, the one that listened across bands reserved for telemetry, amateur experimentation, and a thin sliver of passive astrophysical observation, registered a pulse. In isolation, pulses were not unheard of. Solar flares, meteor bursts, echoes from the upper atmosphere, and the everyday chatter of terrestrial transmitters sometimes bled up to low Earth orbit like a tide of indifferent noise. But this pulse, repeating signals are stubborn things. A single beat can be an accident. Repetition is the mark of persistence. The receiver software, designed for the grindingly practical job of cataloging and alerting, elevated the event from passive datum to flagged entry. The waterfall plot that normally crawled by with a sedate indifference sprouted a thin, obstinate line. The line pulsed with a cadence that suggested pattern rather than chaos. It was faint, like an ember seen at the edge of a smoulder in a room of white noise, but it kept its rhythm. There is a peculiarity to how groups in controlled environments experience this. The alert did not rip through the station like thunder, it moved like a ripple of focused awareness. Instruments, because they are built to be obedient witnesses, told their stories in numbers and light. The log system appended an entry in the passive voice, anomalous narrowband emission detected at 1382.27 MHz. Repetition interval approximately 9.1 seconds. SNR threshold exceeded. The words were clinical, but the line between clinical and curious is thin when the scale shifts from the habitual. Protocol took its place immediately after curiosity. The station carried manuals and decision trees, pale maps of procedure that translated wonder into process. The first tasks were mundane and necessary: confirm local interference sources, cross-check onboard transmitters, verify that no experiment had been left in a broadcast state. Records of scheduled transmissions were consulted. Telemetry logs were scrolled back and inspected. Nothing in the manifest accounted for the signature. Then the frequency range was cross-referenced with orbital interference databases. Nothing in the catalogue matched the exact finger. What followed was a slow choreography of measurement. The receiver engaged a narrowband filter and hunted for harmonics. Time E-series data were saved as binary files, annotated with UTC timestamps that would later be stitched into a chronological mesh. The waterfall display was frozen, magnified, and replayed in loop. In the slowed frame, the pulse looked insistently human. A spike, a fall, a quiet interval, a spike, a fall, a quiet interval. 9 seconds between spikes like the steady tick of a very patient metronome. There was a faint drift in frequency. Speculation is a dangerous thing in an environment built on verification. For discipline, the watch turned to the mundane apostles of explanation. The station ran a quick scan against known pulsar databases because pulsars are the canonical repeating radio sources that entered the human lexicon long ago. The pulse did not match any known pulsar catalog entry. Solar indices were checked. The sun's activity was unremarkable. The ionosphere was quiescent. Amateur radio logs were consulted for coincident entries. Silence answered the queries. When empirical channels fail to close the loop, the human mind supplies a narrative. The reaction aboard the outpost, however, was not a flight into fantasy. It was a tilt toward a specifically patient kind of wondering, that mixture of scientific discipline and ancient awe that discerns possibility without capitulating to it. The line on the waterfall was allowed, for a while, to remain simply that, a line that must be respected, investigated, and recorded. The log file accrued minutes as if counting footsteps in a corridor. Those minutes were full of small, tactile details that the majority of human experience never notices. The fluorescence of indicator LEDs cast a greenish pallor across gloves and maps of printed procedure. The humidity control clicked to rebalance a fractional rise. Condensation beadlets gathered along an instrument chassis, barely perceptible. A pot of water heated in a microskettle completed its cycle and clicked off, the sound of domestic punctuation against a room of sophisticated humming machines. Paper forms, now anachronistic in an age of digital continuity, lay in the corner, printed checklists, annotated. On the data side, the signal displayed a certain symmetry. The pulses were narrow in bandwidth, concentrated in a few kilohertz, an economy that suggested deliberate engineering rather than astrophysical breadth. Natural sources tended to smear energy across bands, unless governed by a well-understood mechanism. The narrowband nature hinted at a carrier, the language of transmitters rather than singe-my-mission celestial bodies. It was suggestive, not conclusive. The repetition interval was steady. Statistical analysis over a few dozen cycles found variance within instrumental, yet the measure of significance in such contexts is not merely statistical. Long experience in listening to the sky teaches caution. Signals that seem purposeful by a first reading often collapse under deeper scrutiny into mundane origins, harmonics, aliasing, multipath reflections, or simple human error. But there is a separate class of events that evade immediate categorization and cling, with an obstinacy that is both maddening and seductive, to the notion that something else is present. An imprint sent across electromagnetic seas that feels like a question. The station marked the event for uplink. In the bureaucracy of space operations, information flows along channels that are as much administrative as they are technical. The raw files, the annotated waterfall images, the spectral fits, and the timestamps were packaged into a message and queued for transmission. A ground center would receive, corroborate, and decide whether to elevate the event up the ladder of attention. Transmission windows were finite, carved out by orbital geometry and bandwidth priorities. The queue waited for the next pass. Between the detection and the delivery of the message, the station did what it could. It increased observation cadence. It broadened the aperture of listening to adjacent bands. It deployed an alternate antenna to cross-validate. Redundant systems, skeptical by design, were allowed to be corroborative. The resulting datasets were patient and unflinching. More pulses, same cadence, same faint Doppler drift. The station took snapshots at higher sample rates, noise floors were subtracted, and spectral baselines renormalized. Each procedure succeeded in producing a more precise picture of the phenomenon, and each success deepened. What mattered, in the long view, was what such an occurrence implied about time and memory. The signal, if it were intentional, represented an act of communication stitched into a medium that forgets easily. Electromagnetic waves are ephemeral messengers. They spread, attenuate, and become indistinguishable from background after billions of kilometers. The odds of persistent, intelligible messages crossing the gulf of space without a planned receiver are small. Yet the very fragility of such transmissions is what makes them philosophically luminous. A pulse that persists deep time complicates the inference. A signal intersecting a station in low Earth orbit might have been generated yesterday, 1,000 years ago, or millions of years in terms of its source's lifespan. Time in the cosmos is a scale that resizes urgency into curiosity. Even the most intimate signal, when measured against geologic epochs, can feel like a flicker. The signal, therefore, becomes not merely a thing to identify, but a narrative device for contemplating erasure and endurance. What kind of agent would be content to send a few modest pulses and let them wander? Well, the station's recording systems, unambiguous and indifferent, archive the data. The act of archiving is itself a kind of insistence. Humans and their artifacts have long sought to preserve traces, to make small beacons against oblivion. The decision to preserve, to tag, and to transmit the observation to ground centers was an act of collective stewardship, a choice that committed a fragment of the station's limited memory to an uncertain future. It was also a ritual familiar to anyone who has ever kept a journal in the night. The desire to mark a strange observation before dawn steals it into routine. Outside the strict chain of technical logics, the pulse acquired other meanings. For those steeped in the history of human attempts to read patterns in the sky, the pulse was a narrative seed. It fed into an imagination that treasured ruins and echoes, ruined cities erased by erosion, languages lost to drift, artifacts ground into soil. The pulse could be an artifact of a civilization that had already passed beyond recognition. The idea is old, almost mythic, that civilizations might leave behind only whispers, and that the patience of future listeners is the only hope. And yet the watchers remained humble. Humility in such a context is not defeatism. It is a methodological acknowledgement that the cosmos offers many ways of lying to the unwary. A disciplined listener holds options open, natural and artificial causes, local interference and distant beacons, human error and genuine novelty. The station's logs reflected that multiplicity. The incident was tagged with multiple confidence intervals. The word unidentified sat beside narrowband like a brief epitaph. As the night deepened and Earth turned under them, the pulse persisted. The pattern did not escalate into something larger. It neither embedded a message in wide modulation nor unfolded into a frequency sweep that would betray a more complex encoding. It remained stubbornly simple: pulse, silence, pulse. In its simplicity lay its power. Simplicity is the shape of intentionality that demands translation. It can be a doorknob waiting to be turned, or a drumbeat in a lonely hall. The archival routine concluded in the late morning of a different time zone. A packet left the station in the next available downlink. Ground systems received, verified, and began their own slow dance of checks. The watch that had first been roused by a console digit returned to the rhythm of maintenance, but not without a change. The small, acute readiness had not dissolved. It had mutated into deliberation. Curiosity had become a task that would be passed through committees and analysis groups, through nights of sober cross-validation and days of speculative modeling. If there was a single mood that the night's event instilled, it was the sense that the universe retained surprises that are patient enough to wait for attention. The pulse did not announce itself with fanfare. It called with the economy of a whisper repeated. It did not demand immediate comprehension. It demanded that the habit of listening be honored. In the context of deep time, the spacecraft's ephemeral vigilance, a few people, a handful of machines, a narrowband receiver, was an act of fragile continuity. The station, like a lighthouse keeper who watches empty seas for ships that occasionally appear in fog, the record ended that shift. not with resolution, but with the simple fact of continuation. The pulses continued. The files were complete. The message had been sent. The question the night opened was now in the hands of many sober minds, but the kernel of it remained the same as the first line on the waterfall, a repeating mark in a vast indifferent field. It was small, it was temporally localized, and yet it suggested narratives that stretched beyond the station's orbit into the deep past and possible futures. In those quiet hours, when the planet below turned away and the instruments kept their vigil, the universe offered that narrow, bright insistence, a pulse that kept time somewhere between silence and meaning. The station listened, recorded, and passed the data along. That was all that could be done in the face of such an occurrence, and it was also, for a moment, everything. What does a signal say when it refuses to behave like anything the sky has taught us to expect? The question hung in the sterile light of the outpost, as if the instruments themselves had been compelled to ask it. The narrowband blip that had first crept onto a waterfall display was no longer an oddity in a ledger. It had become an object of study, a small patient sculpture carved out of noise. The next stage of any such encounter was to examine the texture of that sculpture, not with metaphors but with measurements. If the cosmos speaks in weather and chaos, then the laboratory must respond as a translator, turning rhythm into statistics, spikes into hypotheses, and frequency into a map. On the face of it, the anomaly had unmistakable properties that set it apart from familiar cosmic broadcasters. Its carrier occupied a single, immaculately narrow slice of spectrum. Natural radio sources, be they thermal emissions from plasma, the broad Mars action of interstellar clouds, or the broadband hiss of lightning storms, smear energy across wide bands. This was not smear. It was a concentrated line, almost surgical in its confinement. The repetition interval between pulses, the steady 9-second cadence first logged in the waterfall, persisted across hours and then days with a stability that could not be casually distinguished. Quantitatively, engineers and scientists aboard the outpost applied the instruments of suspicion. Fourier transforms and autocorrelation functions became the grammar with which the phenomenon was described. Spectral analysis returned an almost trivially simple result. Power concentrated in a few kilohertz, harmonics either wholly absent or suppressed beneath detection thresholds. The autocorrelation revealed structure at intervals consistent with the pulse duty cycle, and cross-spectral density measurements across adjacent bands showed no broadband companion emissions. When statistical metrics were computed, there are other, more pointed tests that the field of signal detection has developed for distinguishing the intentional from the incidental. Modulation schemes used by human transmitters leave identifiable fingerprints, amplitude modulation, AM alters the envelope of a carrier in a continuous way, frequency shift keying FSK hops the carrier between discrete frequencies, phase modulation rotates the carrier's phase. The outpost's demodulators attempted a battery of decodings. Pure AM would have revealed a simple envelope, FSK would have shown discrete lobes, phase patterns would have unmasked cyclic symmetries. None of these standard schemes produced intelligible patterns. That possibility carried with it the suite of implications. First, the source. Wherever it lay had the capacity or reason to transmit deliberately narrowband emissions. Narrowband is the language of efficiency. To concentrate power into a thin spectral line is to ensure detectability against a noisy background with less energy. Second, the patterned amplitude alterations hinted at a conscious imposition of structure. Whether that structure was a clock, a checksum, an identifier, or a fragment of a more complex stream was not yet evident, but the asymmetry between the carrier's stasis and the envelope's variance felt meaningful. If the spectral character promised artificiality, the spatial question begged for answers in equal measure. A single receiving station in low Earth orbit cannot intuitively turn a line on a screen into a birthplace on the sky. The problem of localization is, in essence, a geometry problem complicated by the intransigence of motion. The station's motion, a constant orbital sweep, provided the first handle. Doppler drifting of the carrier frequency over the course of a pass suggested relative motion between receiver and emitter. The measured drift could be mapped, with the calculus of orbital mechanics, into a family of possible radial velocities and, by extension, possible. Beyond Doppler, the station exploited another classical technique, time difference of arrival. When the same pulse is seen by two spatially separated receivers, the tiny difference in timestamps gives a hyperbolic locus on the sky. The more receivers, the smaller the intersection zone. At the moment of initial detection, the outpost was alone. It could only prepare its case and solicit corroboration. The packet of raw samples, annotated waterfalls, and timestamps were queued to ground arrays and to a wider network of passive monitors. A mosaic of observatories, units of very different sizes, sensitivities, and vantage points. Estimates of the source's effective isotropic radiated power, ERP, further narrowed the possibilities. The signal's flux density, when corrected for the receiving antenna gain and known free space losses, suggested that if the emitter lay at lunar distances, its transmitter could be modest. If it lay at geostationary altitude, it would require relatively little power. If it lay interplanetary, then the necessary power jumped exponentially. Those simple energy calculations are blunt instruments, but they force the mind to sketch scenarios. A weak transmitter in near space, a moderate beacon on a small. The spectre of reflection is a pragmatist's favorite explanation, and it deserved careful attention. Radio frequency energy can bounce off rocket bodies, metallic fragments, even space debris and unexpected geometries, creating time-delayed echoes or spectral compressions. Such specular reflections often betray themselves in polarization changes, in frequency smearing from multipath interference, or in the presence of signal replicas offset slightly in time. Meticulous polarization measurements and cross-on-antenna phase analyses were performed. The signal's polarization remained. Catalogues were consulted with a formality that verged on ritual. Every registered transmitter, every defunct satellite with the potential to chatter, every scheduled experimental beacon was checked against the detected fingerprint. The absence of a match is a kind of negative evidence that is both liberating and oppressive. Liberating because it clears familiar culprits off the table, oppressive because it widens the field of unknown. Amateur radio logs were scoured. ALO, allocated frequency occupancy. Tables were checked, interference registries were examined. Each empty result tightened the net around the person. Across this technical lattice, the human institutions responsible for stewardship of the signal had to make choices. Information had to be prioritized and transmitted. The outpost's message package grew. Raw IQ samples, timey stamped metadata, cross-correlation outputs, spectral fits, polarization vectors, and notes on instrument health. Each component was a claim, a small, bureaucratic assertion that the thing was real and worth the cost of attention. That package moved through queues and filters, grazed the schedules of larger dishes, and invoked the attention. And what did that waveform offer? Patterns within patterns, the amplitude oscillation within pulses, occasionally grouped into clusters, a loud, soft loud sequence repeating a larger cycle over many pulses. One could imagine, as analysts did, that such groupings formed the bones of a simple encoding, perhaps a binary stream where loud equals 1 and soft equals 0, perhaps an integer count, perhaps pulses arranged in prime lengths to advertise intelligence. These are the familiar motifs of contact law, primes, Fibonacci numbers, simple mathematical motifs that, in principle, any universal intelligence might recognize. This uncertainty became a narrative driver. Without a smoking gun of modulation that maps cleanly to a known encoding, the community of listeners practiced a particular kind of humility. A measured skepticism crept into the language of reports. Hypotheses were ranked, confidences were assigned, and the vocabulary of possibility was applied with restraint. The signal became a case study in the sociology of attention. What is elevated to global notice and what is archived as a curiosity depends less on the raw data than on the resources willing to be committed to follow it. Yet in the quiet rooms where the data were examined, philosophical currents surfaced in the margins of the scientific work. If the emission were a relic of a civilization that had already been erased by time, What strategies might such a civilization adopt in order to be legible to the far future? One plausible design principle is redundancy and simplicity. Luxuriant modulation rich in information decays into indistinguishability. Simple, robust beacons endure. A narrowband tone punctuated by a low alphabet amplitude sequence might be an attempt at archaeological messaging, not to transmit a library, but to announce a presence with a sustainable low-energy signature. Another principle is localization efforts began to yield a narrowing of possibilities. As independent observatories reported detections, or the absence thereof, the hyperbolic curves of time difference intersected with Doppler cones and constraint surfaces carved by orbital mechanics. Probability maps, once broad arcs across the sky, condensed into smaller patches. The region of most likely origin could be plotted as a heat map on a celestial sphere, an irregularly shaped island of higher probability surrounded by seas of uncertainty. That island shifted as more data streamed in, responding to yet each increment of resolution brought with it new puzzles rather than solutions. The most probable patch included regions overlooked by typical sky surveys, obscure orbital niches, parts of near space catalogued poorly, and trajectories that intersected with debris clouds whose histories were inadequately known. The microecology of near space, the graveyards of rockets, abandoned reflexive surfaces, and small bodies temporarily captured in Earth's gravitational gossip, is not a pristine place. It is a palimpsest of human activity layered atop natural processes. The possibility that the pulse originated from some human artifact, whether the station and its partners adopted a posture of patient inquiry. Observational campaigns were scheduled, not with the fever of immediate drama, but with the cautious optimism of long projects. Large dishes were booked to stare at the heat map island for extended stretches. Array telescopes were asked to form interferometric baselines to shrink error ellipses. Lower frequency arrays measured the noise floors across the candidate region. Parallel to observational work, archival hunts went deeper. Old telemetry, mission ephemerides, and decommissioned payload manifests were re-examined. Through all of this, the pulse itself remained steady. It neither evolved into a complicated cascade nor fell silent. In its persistence, it exerted a slow pressure on the collective imagination. If one wished to be poetic, one might call it a heartbeat exposed on the skin of time. Small, patient, and idiotically resilient. It measured something like constancy in a universe otherwise dominated by flux. Localization, in the end, is less a moment than a process. Each measurement, each downlink, each corroborated detection tightens the noose of probability, shifting the most likely scenarios. The heat map shrinks, hypotheses are retired, and new ones take their place. The outpost sent its data and maintained its vigil, contributing one strand to a wider net. If the pulse was a message, then the act of localizing it was the first reciprocal gesture, attention returned in kind. If it was a relic broadcast, then the localization would yield a place where colleagues could go and stare. In a deeper sense, the entire exercise folds back into the question of time. The pulse existed in an instant on the screen, yet its implications stretch like geological strata. Is the impulse of some long-gone engineer preserved in a thin spectral line, or is this merely another example of human propensity to read stories into patterns? The tools of detection and localization are designed to answer such questions pragmatically, but they are also instruments of narrative. They help convert an anonymous blip into a place, a probability, a history to be interrogated. The map that emerged at the end of the first weeks was a compromise between certainty and wonder. It was not a pinpoint nor an explanatory essay. It was a set of coordinates shaded with probabilities and annotated with caveats. The smoking gun deferred, the story still unfolding. The pulse continued to mark its 9-second cadence, indifferent to human timelines. The localization effort, patient and methodical, kept pace in its own slow time, building a scaffold that might, in days or years, be climbed toward firmer knowledge. Until then, what does it mean when a whisper, caught on a receiver meant for routine housekeeping, is suddenly mapped to the rim of a nebula 1,000 light-years away? The question arrived not as a manifesto but as a dataset, numbers, timestamps, and a thin-band radio signature that, when folded through layers of geometry and plasma physics, pointed to a place nobody on Earth had ever really looked at closely. The preliminary localization that crawled across analysts' screens did not read like a neat address on a map. It read like an invitation to a blank. It said, "Edge of a nebula, thousands of light-years distant, region scarcely surveyed in modern catalogues." The implication was simple and destabilizing at once. The shift from here to there was a work of incremental mathematics. The Doppler drift measured over the station's pass had suggested a non-E-local source. Time E difference of arrival solutions, once supplemented by corroborating detections from a network of ground arrays, closed the error ellipses into a patch that intersected the nebulous boundary. But distance is a stubborn thing. The airless geometry of space does not permit casual estimation. The most persuasive of the early indicators was dispersion, the way the signal's arrival times changed with frequency. The group delay across the band, reasonably free of near-Earth ionospheric contamination. For scientists, numbers are a kind of grammar for astonishment. They had felt, a few weeks earlier, the peculiar twinge that comes when an anomaly refuses the comfortable categories. Now those numbers gestured toward scale. A nebula is not a quiet place. It is a churn of charged particles, filaments threaded with magnetic fields, and density gradients that refract and scatter radio waves like glass. Edges of nebulae are places of boundary physics, contact zones between ionized interiors and colder molecular outskirts. The location therefore offered two paths of inference. The first was the prosaic, the signal. The initial analysis proceeded along multiple methodical fronts. Spectroscopy of the sky patch, assembled from archival HAO and radio surveys, revealed filamentary structure. Faraday rotation measures across background pulsars hinted at fluctuating magnetic fields, and polarimetric data from the detection itself showed a coherence that was not easily explained by multipath scattering alone. The pulse's narrow spectral confinement and remarkably low entropy suggested compression, a hallmark often interpreted as engineering. But the universe has ways of mimicking craft. There were practical sequences in the analysis that read like ritual. Time-tagged raw IQ samples were downloaded in triplicate, checksum verified, and reprocessed through independent pipelines to rule out algorithmic artifacts. Fourier analyses were followed by wavelet decompositions. Modulation decomposition algorithms were applied with differing priors. Simulations of plasma lensing were run against the measured amplitude modulations. Each run yielded outputs that were both clarifying and maddeningly equivocal. Plasma lensing could plausibly focus a faint distant beacon into a narrow, bright spike with The scene of work was not cinematic, but tenderly real. Servers hummed, logs inked themselves into long files whose names were themselves tiny monuments to caution. Monitors threw up layered heat maps and probability contours, while printed cutouts of survey plates lay scattered across tables like the flattened leaves of some slow book. Coffee cooled in insulated mugs. In the margins of a research note, someone had sketched a schematic of a dense filament bending a plane wave and annotated it with the phrase, "amplifies by factor X under slow drift." No single aesthetic dominated. There was an undercurrent of affect that could be felt without being spoken aloud. The work instilled an economy of feelings, a rising, careful excitement tempered by professional humility, a pinch of dread over premature claims, a fierce protectiveness over the integrity of data. In the public mind, such discoveries are often imagined as sudden epiphanies revealed by bold pronouncements. In practice, the encounter was painstaking, conservative, and almost ritualistic in its deliberation. The scientists operated as custodians of uncertainty, cautious judges of plausibility. The nebula's rim offered additional, tantalizing possibilities precisely because it had been poorly surveyed. Large telescopes and wide-sky surveys had, for decades, prioritized certain bands and certain targets. There are many corners of the interstellar medium that have been seen in passing, but never excavated with focused attention. Those edges can be repositories of archival phenomena, stalled shocks, relic magnetic structures, pockets of high-density gas that survive far longer than their creators. If a civilization had once situated a transmitter in such a thermally inert niche, a deeper line of inquiry concerned time itself. The signal's arrival time was not a message in human present tense, it was a sample of arrival time, a datum whose origin event could have taken place centuries or millennia earlier. Light nighttime and radio time complicate any simple causal reading. A transmission sent 1,000 years ago from a region near a nebula's edge would arrive now, and the conditions it encountered en route could warp it, refract its band, or strip it of ancillary signatures. The scientists accounted for light travel time not merely as an arithmetic correction, but as a philosophical contour, a message. Practical choices multiplied. Observational campaigns were reprioritized. Powerful dishes with high spectral resolution were petitioned for long, uninterrupted stares. Interferometric arrays were asked to form the baselines necessary to shrink the sky patch into a pinpoint. Submillimeter facilities were queried for molecular line studies to better constrain the physical state of the nebula edge. In parallel, data archaeologists dove into archives, low-frequency transient surveys, mission ephemerides of long-retired spacecraft, and photographic plate. The analysis also triggered a slow interplay between scientific method and narrative imagination. Hypotheses were weighed and annotated with confidence intervals, yet alongside them was a human tendency to consider grander scenarios, a beacon designed for deep time, a technological relic camouflaged by plasma, a deliberate marker intended to outlive an origin species. Those speculations were disciplined by the metrics of power. The required transmitter strength for a signal to be detectable at interstellar distances is brutal arithmetic. A low-power transmitter at thousands of light-years would be invisible unless there were, of course, perfectly natural astrophysical mechanisms that could produce narrowband, repeating structures, molecular mazes operating in particular rotational transitions, pulsar echoes interacting with plasma sheets, or magnetospheric resonances in exotic objects. Each mechanism came with a suite of signatures to seek specific spectral line identifications, predictable polarization swings, or correlated emission in other bands. The scientists set out checklists of telltale signs, and the nebula itself provided a laboratory of sorts. If certain molecular species were abundant at the rim, spectral lines. As days passed, the signal retained its rhythm. That very persistence became a kind of force multiplier. It allowed deeper integrations, better signal-to-noise ratios, and finer tests to be run. Time, the great distiller, helped clarity where snapshots could not. The researchers found themselves inhabiting an epistemic middle ground, neither convinced of a mundane origin nor seduced by a spectacular claim. In the background lurked the wider human context, whether to communicate updates to the public, how to coordinate cross-agency observation time. At moments, the work acquired a ritualistic cadence. Night after night, the scientists returned to the same displays, rechecking the same coherence tests, annotating results as though leaving footnotes for future readers. There was an awareness that they were not merely assembling evidence but also authoring a record. If the signal proved to be a geological echo of technological activity long gone, then these archives might be the primary text future analysts would read. This sense of custodianship fed a subdued pride, not the flamboyant victory of discovery, but ultimately, the initial analysis did not collapse the possibilities into a single narrative. Instead, it opened a palette of plausible stories, each shaded by different assumptions about environment, engineering, and time. The nebula's rim transformed from a nameless backdrop into an attractor of hypotheses. It was a place where boundary physics could stage tricks of amplification, and where a long-forgotten transmitter might, against all odds, persist. Whether the signal was the engineered voice of a remote agent, a natural astrophysical concerto, or an artifact of scattering, the act of mapping it onto the pulse continued to mark time in its thin 9-second way. Each detection was a metronome click pulling a slow chorus of telescopes and archives into sync. The nebula's edge had become a place to be checked, an object of astronomical attention and philosophical pondering. The initial analysis had not solved the puzzle. It had, in a more consequential way, reframed the terms on which the puzzle would be approached. The world of instruments and institutions rallied to that reframing, not with bluster, but with the steady rigor of people who know how to wait and how to measure. They had found, on the rim of a cloud that had been quiet in human catalogues, a narrow incision. What language does one choose for a message intended to outlast memory? It is not a trivial question. In the history of attempts to speak across the void, the oldest and arguably safest choice has been not poetry or picture, but mathematics. The neutral grammar that, in principle, any intelligence with the capacity to count might recognize. When the outpost's packet of raw samples reached the ground, it did not land in a theatrical auditorium. It arrived in tacit places, shielded basements, radio-quiet vaults beneath iron and concrete, where racks of equipment hummed like subterranean. The underground analysis began with a procedural modesty. The first acts were defensive, make sure what was in hand was what it claimed to be. Checksums were run, clocks were compared, antenna gain patterns were reconstructed and verified. Those chores possess their own kind of poetry. Hours of attention devoted to confirming that the world is as fragile instruments recorded it. Once provenance was secured, the signal was unwrapped layer by layer, not in the hope of immediate revelation, but in the determination of leaving no plausible natural explanation untested. The signal's simplest feature was its stubborn periodicity, 9 seconds, give or take a sliver. That cadence, persistent across orbits and across different receivers, was the hook that drew analysts in. But rhythm is deceptive. It can be a sign of natural oscillation or of a deliberate metronome. The subterranean facilities applied the familiar arsenal of time usuries analysis, autocorrelation to hunt for repeat spacings, wavelet decompositions to resolve nested structures, and spectral estimators to inspect for harmonics and sidebands. The more they looked, the more the signal revealed hierarchical timescales. Inside the 9, to the modern listener trained in both signal processing and caution, such nested regularity meant one of two things. Either nature had conspired to render a complicated dynamical system into a clockwork of unlikely coincidences, or an agent, deliberate in some fashion, had constructed tiers of timing to encode information at multiple scales. The difference is the difference between random murmuration and sentential grammar. Statistical measures were the tests applied next. Entropy estimators returned values not of chaotic abundance but of compressibility. Kolmogorov proxy. Compressibility alone is not proof. A maser cavity in a particular rotational transition can produce narrow features and reproducible pulses, and plasma lensing can sculpt and amplify a passing carrier into strikingly regular trains. The subterranean teams took such mechanisms seriously, simulating models of molecular masers, magnetospheric resonances, and plasma sheet focusing to see whether natural physics could manufacture the observed nested periodicities. Yet time and again the simulations faltered in one crucial respect: the detailed sequences of micropulses and their groups. The first headline-friendly breakthrough arrived not as a decoded sentence, but as a structural fingerprint, a clear sequence of pulse group lengths that, when represented as integers, it was a slender and cautious result. The mapping from pulse groups to integers requires a choice: how to partition a waveform into discrete tokens, how to treat amplitude differences as symbols, how to assign units of time into counts. Different choices produce different integer sequences. The analysis teams therefore behaved like conservators, not prophets. They enumerated all reasonable encodings and checked whether any of them produced strikingly non-random integer sequences. It was in that careful provisionality that the signal's probability of being engineered leapt. Prime numbers, simple and foundational, have long been proposed as the first culture-agnostic statement of intelligence. Counting without a shared vocabulary implies counting itself. When a sequence analogous to primes emerged from the subterranean analyses, it did more than suggest intelligence. It suggested intentional pedagogy, an attempt to present a basic, indisputable set of concepts likely to be recognized by another counting mind. But primes were not the only motif. Deeper analysis revealed that the pulses were organized not only into a sequence recognizable as small primes, but into a hierarchical structure with repetitive self-assimilar motifs. There were fractal-like recurrences. A coarse envelope repeated every 9 seconds, nested inside, a mid-scale motif repeated every 1.3 seconds, and within that, microstructure at tens of milliseconds recurred in patterns that mirrored the larger scales. This nested scaling suggested something more than a simple list. It implied a meta-syntax, a grammar that encoded structure. The subterranean analysts applied algorithmic compression tests in earnest. If the data were engineered, it should be compressible in ways that align with known coding schemes. Machine learning models trained on human-designed signals, sequences of delimiters, checksums, and small alphabets, found plausible segmentations. Classical encoding tests searched for primo-sequence headers, for simple counts, for integer factorization patterns, and for modular residue structures. Some decoders suggested the presence of markers that could operate as synchronization headers, short, unique bursts that repeatedly punctuated the loop. One of the riskiest and most revealing maneuvers was a thought experiment, given practical form. Treat the pulses as a message built for deep time. A sender that intends longevity, not just short-term contact, would choose encoding strategies resilient to Doppler shifts, dispersion, and partial loss. To test this, analysts simulated extreme propagation distortions and asked whether the putative code held together. Remarkably, when the data was stretched, jittered, and clicked in simulations, the coarse primary-like skeleton persisted. Microstructure. All of these inferences raised, in parallel, uneasy ethical and institutional questions. The subterranean vaults were not secretive outposts of paranoia, they were repositories of prudence. Protocols existed for verification, for cross-checking with independent observatories, and for assessing the public and diplomatic dimensions of any announcement. The work required an unusual combination of skills, radio engineering rigor, mathematical sensitivity, and a historian's patience. The analysts filed reports with careful qualifiers. Every claim was beyond institutional caution, lay a more existential heartbeat. The idea that a mathematical structure could be transmitted across deep time and be recognized now by species whose own counting systems are bound to silicon and bone is an emotional architecture as much as a technical one. On a human scale, the response was complex, wonder folded with an almost anthropological melancholy. The possibility that the signal was a deliberate act of remembrance, a civilization placing a simple arithmetical torch in the dark with the hope that someone, someday, might notice, made the subterranean. The analysts continued to probe alternative natural processes with equal vigor because the integrity of the finding depended on exhausting plausible physical explanations. Could a molecular maser in a peculiar rotational state, modulated by a passing shock front, produce repeating amplitude tiers that mimicked an encoding? Could coherent plasma effects in the rim of a nebula sculpt a carrier into a succession of delays that, once quantized, matched small prime sequences? The subterranean computations explored those scenarios in depth. Many natural processes were persuasive in some respects. There was also a peculiar technical nuance that increased conviction. The repetition frequency bore an internal logic responsive to motion. The 90-second clock was not a blind metronome. Over long integrations, analysts detected tiny pattern deviations that correlated with modeled Doppler trajectories. Those deviations were not random drift. They matched a compensatory modulation a transmitter might use to neutralize relative motion between itself and potential receivers, inserting small retiming cues in the signal that would allow an observer to reassemble the message robustly. In other words, all of this yielded a new ordering of probabilities. Engineers and mathematicians assigned Bayesian weights. Conservators of evidence insisted on redundancies. The subterranean analyses did not claim certainty, they raised the odds. A priori, the chance that a single narrowband emitter in a complex astrophysical environment would by accident produce a compressible, prime-like, nested sequence is vanishingly small. The cumulative evidence, repeated detection across instruments, the match to primer-like sequences under reasonable symbolization choices, the nested self-assimilar timing resilient to simulated that shift rearranged conversations beyond the underground labs. Astronomical observatories reallocated time. Archives of centuries of radio observations were scanned for forgotten matches. Theological thinkers and philosophers debated the ethics of interpretation. The signal, once a small blip on a waterfall, had become an object of human attention with implications that were not merely technical but profoundly cultural. If mathematics had been chosen because it travels well in time, then any discovery of mathematical structure in a remote emission is both a scientific milestone and a human mirror. It reflects back our own hopes about what counts. At the same time, the subterranean teams retained their procedural humility. The signal's structure increased the probability of intelligence, but it did not convert skepticism into dogma. There were always more tests to run, cross-spectral comparisons, polarization coherence checks across widely separated receivers, and deeper compressive analyses with purpose-built decoders. Each test was an investment in the truth-seeking process. Each negative result was as informative as a positive one. The underground vaults continued to hum. Servers queued new decodings. Archived packets were reprocessed with updated priors. In the slow, patient tempo of rigorous inquiry, the emission began to look less like an isolated artifact and more like an invitation. Whether that invitation was sent by a mind now extinguished, a far-flung transmitter left to drift on the edge of a nebula, or an artifact of the interstellar medium shaped by rare physical circumstances, the consequence was the same: attention returned in kind. In deep time terms, a compact string of pulses is an almost comically modest monument. Yet modesty is where endurance often hides. Mathematics, being portable across epistemologies, serves as a hinge between worlds. The subterranean analysis, its procedures, its hesitations, and its quiet thrill had unearthed a mathematical skeleton within the haze. That skeleton increased the plausibility that the pulses were not random noise, but an artifact of intelligence, a small, patient signal cast into a vast, indifferent sea. It did not yet answer the larger question of authorship. The repetition continued. The 9-second heartbeat kept its cadence, and within each beat, the same nested motifs surfaced like the same footfalls at different speeds. Each detection fed the underground archives. Each decoded hypothesis refined the models, and each failed natural explanation illuminated the contours of possibility. The analysis under the earth became, in the best sense, an act of stewardship, not of a treasure, but of a question. A question posed by a structured whisper in the dark that asked simply whether the universe had ever become intentional about what is a signature, if not a number left where time can find it. The question took shape not as an epiphany, but as an arithmetic ghost in the data set and heartbeat already catalogued, a metronome that unfolded over minutes rather than seconds. For many weeks the phenomenon had been a patient object of scrutiny: nested pulses, compressible structure, faint primary-like motifs, and yet it was the discovery of a longer, quieter cycle that reframed the entire encounter. When the long per-period analysis finally resolved, the period was close to 100 seconds. The convergence on this and quantified was the kind of coincidence that made the room of instruments tilt toward a particular kind of thinking. The number 100, the path from detection to interpretation, was long and algorithmic. Analysts did not leap to metaphors, they folded data. They applied classical tools, periodograms, Lombard-Gargle analyses for uneven sampling, phase dispersion, minimization, and more pragmatic stacking techniques. Because the signal-toy-noise ratio was marginal on single captures, the key was to align many pulses coherently. When waveforms are stacked after much care, corrected for Doppler shifts, normalized for antenna gains, and trimmed of systematic artifacts, faint periodic, the statistical story had to be rigorous. Multiple pipelines, independent software stacks, differently clocked receivers, and geographically separated arrays all returned the same slow period within uncertainties. The analysis ruled out local aliasing and onboard instrumental modulation by cross-checking housekeeping logs, comparing with clock temperature coefficients, and injecting synthetic signals to test for algorithmic bias. Tests for beat patterns, interactions between the known 9-second microcycle and plausible orbital sampling aliases, were exhaustive. After weeks of elimination, the slow, roughly numbers carry cultures as well as meanings. The fine structure constant, law, is a dimensionless ratio that quantifies the strength of electromagnetic interaction. Its inverse, historically rounded to 107, has been a locus of mystique, a clean integer standing in a universe full of messy decimals. To encode the inverse of phi into a timing pattern is to point toward a common substrate of physics. A potential way to say, in the language of bodies and spectra, we know what it is to count the charge of the electron. That implication raised two separate but intertwined lines of thought. One was the technical. The 100-second cycle solved a practical decoding problem. The 9-second pulses already suggested a compact Lao alphabet encoding, amplitude tiers, simple delimiters, primary-like sequences. But such microstructure is vulnerable to noise, Doppler smearing, and propagation distortions. A slow, overarching period can act as a frame, an outer protocol that organizes bursts into larger packets. When analysts folded the time series modulo 137 seconds, the nested microstructures aligned into repeating envelopes, trains of 9-second. From an engineering perspective, this is elegant and conservative. A transmitter intended to be noticed across epochs would favor redundancy and resilience. Simple, slow framing reduces susceptibility to timing jitter. It permits integration over long baselines and allows receivers with crude timekeeping to reassemble the message. It is an encoding strategy more pastoral than theatrical, not a parade of complex modulations, but a clockwork of frames and markers built for durability. The presence of such a frame was itself an interpretive hinge. It suggested design choices aimed at deep time-led verification multiplied. Independent observatories reprocessed archived captures and applied the 170-second folding. Where single passes had previously been too noisy to reveal much, folded stacks cohered into clearer templates. Cross-correlation improved. Signal noise increased with the square root of the number of folded segments, revealing subtle amplitude modulations and recurring microseconds that had been lost in the background. Those templates showed that the 137-second marks were not random flukes, they had a reproducible phase. Statistical models then asked the hard question: what were the odds that such organized hierarchy, 3 scales of timing with consistent repeatable markers, could arise naturally in the astrophysical contexts under consideration? Simulations of plasma lensing and maser action were revisited, not dismissed. Plasma filaments, maser cavities, and magnetospheric resonances are capable of producing narrow, coherent features and of imposing timescales via rotation or shock crossing. But replicating the observed nested hierarchy and the particular slow period proved difficult. The 137 cycle did not behave like a resonance tied to local microphysics. It behaved If the presence of 137 seconds was a signature, could it be? The analytical community treated the number as a potential meta-am marker. One reading was that the slow period functioned as a deliberate pointer to physics, an invitation to translate the message in units familiar to an observer grounded in the same electromagnetic laws. By choosing a period near the inverse fine structure constant, a sender could be saying, in effect, interpret in the language of V. This is not a hubristic claim that a sender expects a human interpreter to understand the historical significance of 107. Rather, it is a choice that privileges. Another reading emphasized practicality. The inverse of phi is a number around 137, and a human transmitter would know that long, rounded integers are convenient for framing. It is easier to retime a transmitter to a slow integer cadence than to attempt an exotic timing that has no simple replicable representation. Thus, the use of 137 could be an instance of convergent engineering. Any transmitter seeking longevity might independently pick a large, memorable integer for framing. The cultural resonance with human physics could be coincidental, or it could be. To resolve this ambiguity required more decoding. The 137-second frames permitted a new kind of symbolization. Where micropulses could be mapped to binary or small alphabets, the macroframes could demarcate message blocks, checksums, and repeating scaffolds for error detection. Analysts tested a variety of encoding hypotheses: amplitude levels mapped to symbols, durations mapped to digits, and multi-ITS synchronization with parity checks embedded across frames. Some decoders produced coherent structures, consistent header markers, repeating checksums whose bound. This is, in effect, a partial decoding. The community did not yet possess a full lexicon or a reliably recoverable narrative payload, but the mechanical architecture of the message began to be readable. It was possible to say with increasing confidence that the emission was not a raw, unstructured burst, but a layered communication protocol. The lower layers carried compact numerical motifs, primes, counts, small arithmetic progressions, while the upper layer provided the scaffolding necessary for long-term coherence. The two worked together. The slow frame-preserved structure. The partial decoding fueled an affective shift across disciplines. Where before the signal had been an object of quiet curiosity, it now acquired the weight of interlocution. The institutions responsible for stewardship felt a new responsibility to treat the data not merely as astrophysical curiosity, but as a possible cultural artifact. That responsibility played out in mundane, essential ways. Protocols for public communication were revisited, archival standards were tightened, data provenance was documented with unusual fastidiousness. Scientists felt a mixture of exhilaration. Philosophically, the resonance with carried a bittersweet intimacy. A signal that gestures toward fundamental constants is a gesture of shared reality, an acknowledgement that different minds, wherever they arise, would encounter the same structural properties of the universe. But such gestures also amplify the sense of smallness. The slow cadence of 107 seconds is modest in the face of cosmological time. It is a humanine scale integer superimposed on a backdrop of millennia. If a transmitter chose that cadence to be read by distant others, it did so with the humility of someone who understands that. The partial decoding also sharpened practical questions. If the emission were a persistent beacon, was it active now, or merely a relic echo? If intentional, what was the transmitter's energy budget? A question with implications for origin scenarios. Calculations of effective radiated power, adjusted by the new understanding of the framing structure, suggested that a transmitter optimized for narrowband efficiency and slow framing could remain detectable with modest power if aided by occasional environmental focusing. That married hypothesis and environment. For the public imagination, the 132nd finding was irresistible. For the scientific restraint, it required patience. The partial decoding produced a richer set of testable predictions. The specific profile of the frame header should recur with fixed phase, interframe checksums should be reconstructible, and a search across archival data folded at 137 seconds might reveal earlier captures hidden in noise. Those predictions were operationalized. Observational campaigns were retasked to include long duration, high-precision timing. Archival datasets were rescanned with the new folding parameter. Amid the pragmatic maneuverings, there remained a quieter aesthetic impression. The 172-second beat functioned like a signature, not a flourish of vanity, but a pragmatic, almost ritualistic act of insistence. A signature in this sense is less about ownership than about address, it says. Whoever we were, we can still count. If the number gestures toward the inverse finer structure constant, it is a way of anchoring an act of remembrance in the most portable arithmetic available. If it is merely an engineer's choice of integer framing, it is still an act of endurance. Either way, the pattern transforms a faint electromagnetic whisper. The unfolding story remained, at the end of the weeks of work, partially decoded and widely consequential. The 137-second cycle had changed the terms of the inquiry, from searching for an anomalous waveform to reading a protocol. The signal had moved, in the space of data folding and careful simulation, from an inscrutable blip to an artifact with architecture. Yet the essential mysteries persisted. Who, if anyone, designed the protocol? For what audience? With what intentions? Was the number 137 a deliberate nod to foundational physics, or a convergent choice of convenience? In that ambiguity lay another lesson about deep time. Signatures that aim for endurance rarely shout. They economize. They choose slow rhythms, robust redundancy, and universals that survive the erosion of context. The 137-second beat is an exemplar of that thinking, modest in scale, rich in implication, patient in its insistence. It asked, in a way that was both technical and poetic, to be recognized across a distance of not only space, but epochs. For now, the partial decoding remained a work in progress, a map with shaded probabilities and clear next steps. Observatories added time allocations, archives continued to be mined, decoding pipelines were refined, and the international consortia that stewarded the data refined their protocols. The sound of servers folding and correlating persisted, a human chorus of attention synchronized to a very slow metronome in the sky. The 137-second signature, whether a deliberate signature or a felicitous coincidence, had become the hinge of the story. What does it mean when a signal stops speaking in abstract pulses and begins to sketch? The question arrived like a cliff in the data stream, not louder, not more energetic, but simply different in register. For weeks the emission had behaved like a terse metronome. Nested timing, compressible motifs, a slow frame near 37 seconds that organized the micropulses. Those features had already nudged the hypothesis of intelligence into plausibility. Now the waveform shifted its rhetorical posture. Within the ordered frames, small clusters of amplitude states repeated in ways that suggested not just numerals but glyphs. A tiny, constrained alphabet, repeated and arranged into. This was not an image presented as a radio photograph. It was a language built from the same economical tools already visible in the message: amplitude tiers, timing delimiters, and framed repetition. The puzzle was to discover the mapping from those tiers to meaningful symbolic forms. The first step was procedural, to treat the message as a two-dimensional array rather than a one-dimensional train. The 107-second frame provided the obvious scaffold. If each frame were a row and the nested 99-second microcycles provided a set of columns, then stacked frames could be reinterpreted as horizontal. There is a kind of quiet poetry to such transformations. A long sequence of delicate pulses, when aligned carefully and averaged, can yield contrasts where none appeared before, the same way a photograph emerges only after long exposure. The process demanded obsessive exactitude, compensating for residual Doppler drift, correcting for slight clock skews across receiving stations, normalizing for antenna gain, and aligning the phase of frame headers so that ephemeral markers stacked coherently. The work was arithmetic and ritual, a series of small mitigations whose cumulative effect was to let faint structure survive the averaging. The resulting lexicon was minimal. The glyph set consisted of a few dozen shapes, each reproducible with surprising fidelity across captures taken at different times and by different instruments. The shapes were not alphabets in any human sense, there were no strokes or fonts familiar to the eye, but they displayed regularities that invited comparison to symbol systems, repetition, reuse in compound constructions, and a hierarchy of size where some glyphs functioned more like separators or punctuation. That alone suggested an organized writing system, not an ad hoc collage. One particular composite glyph arrested attention: a circular motif with radial markers, a central dot, and an outer ring of smaller bodies. A schematic that archetypically resembled what humans have used to depict orbital systems. The drawing was spare, schematic, more like a symbol scratched into clay than an attempt at photorealism. Crucially, this depiction contained an odd addition. Where a familiar 6-member planetary layout might be expected, one of the outer orbits bore a markedly larger body, a planet large in apparent scale relative to its near neighbors and placed offset from a standard orbital. Semiotics became the toolkit. The glyph was not merely a picture, it was a sign pointing to a referent, a place in physical or conceptual space. From a pragmatic decoding standpoint, the analysts treated it as if it contained at least 3 channels of information: an index of identity, which body is the reference point, a scale marker, how to interpret relative sizes, and a positional cue, where in the system the noteworthy body sits. The encoding strategy built into the message favored dimensionless quantities and small integers, the same universals that had emerged before in primer-like sequences and in the slow. How could a handful of glyphs serve as a map, and what map would they be offering? The decoding proceeded in stages of increasing abstraction. First, the glyph's radial marks were quantified: counts of satellites, proportions of radii as integer ratios, and angular placements translated into coarse angular coordinates. Next, the emphasized planet's relative size and orbital radius were examined as deliberate parameters. The transmitter seemingly encoded the planet's size as a ratio to the host star and its orbital radius as a rational multiple of an inner reference orbit. The conversion from glyph to coordinate, however, was not a one-to-Suoni mapping. The same pictographic system could encode several semiotic intents. One reading was expository. The sender was identifying its home system, a catalogue entry with an emphatic marker at one planet. Another reading was invitational. The emphasized planet marked a location for meeting. A third reading combined both. The sender introduced itself and, by highlighting a particular planetary body, suggested that the planet or something associated with it was the locus of some exchange. The ambiguity clues elsewhere in the message offered guidance on which of these readings might be intended. The nested frames and prime sequences earlier decoded suggested pedagogy, deliberate introduction of counting and simple arithmetic. In human practice, such an approach would be suitable for an initial contact. First, the sender proves intelligibility with mathematics, then it transitions to representational content like diagrams. Thus, the pictogram's presence after a sequence of primes and framed headers read naturally as the second act in a carefully staged lesson, demonstrate shared recognizables, then present but an address in what coordinate system? The message's other elements supplied hints. Earlier features showed compensatory retiming at fine scales, adjustments that read like anticipation of a moving receiver, and a slow frame near the inverse fine structure, constant that suggested a preference for dimensionless anchors. These design choices indicated a transmitter that expected physical knowledge in its audience, an awareness that intelligent listeners would have some understanding of fundamental constants and would find dimensionless ratios useful. Therefore, the pictographic map was probably meant to be interpreted in invariant terms, orbital. That is where the earlier localization efforts and the nebula rim hypothesis mattered. If the source was indeed in the direction of the scarcely surveyed nebular edge, then the pictogram might designate a system within that region, an exoplanetary system with an anomalous massive body. The astronomical record offered a limited database for such a hunt. Deep sky surveys catalogue stars and their spectral properties densely in some directions and sparsely in others. The nebula's rim, an astrophysical border region of gas and dust, obstructs optical surveys but is comparatively more Operationally, the search had two modes. One was direct. Take the ratios from the glyph and search catalogue entries for systems whose measured parameters could be rescaled to match those ratios within reasonable uncertainties. The other was contextual. Look for anomalies in the nebular rim consistent with a massive body. Gravitational lensing signatures, localized perturbations in molecular line velocities, or persistent narrowband features in other bands that might indicate artificial structures. Neither approach promised immediacy. The distance measured earlier, thousands of light years. Decoding the glyph as a meeting clue also raised a temporality question. What did meeting mean across geological and cosmological epochs? A rendezvous at a planet 1,000 light-years away is not an appointment in the human sense, it is an act of temporal placement. The sender might have signaled a location to be visited by slow archaeological attention rather than by an immediate physical voyaging. In the language of deep time, a meeting is sometimes best understood as a marker planted in the strata, a deliberate arrangement to be discovered by future minds who will, across the gulfs of light travel, interpret the sign. This interpretive strand had practical consequences. If the glyph were an archaeological pointer, the investigative priority shifted from immediate physical rendezvous to careful excavation of local evidence. Astronomers asked different questions. Are there spectral anomalies around candidate stars that could correspond to artifacts or ruins? Are there unexplained coherent narrowband emissions anchored to a specific object? Does the surrounding interstellar medium show structures that could act as long-lived repositories of material? These were observables within reach of modern facilities, not for transporting. Technical tests accompanied the speculation. The pictographic decoding predicted specific patterns in archival data. If the glyph encoded orbital ratios that correspond to a particular star, then historical radio surveys folded at those parameters might reveal faint, persistent emissions aligned with the candidate coordinates. Similarly, far-infrared mapping might detect unnatural thermal gradients, and high-resolution molecular line studies could pick out localized kinematic signatures. The search thus became iterative: propose a mapping, generate observational tests, fold archival data, and refine. Throughout this methodical work, the emotional undertow was unmistakable. The pictogram's presence altered the tone of attention from distant curiosity to directed intimacy. A crude diagram of a planetary system had humanized the signal in a peculiar way. The symbols were economical, but their implications were grand: identity, invitation, address. There was tenderness in that smallness. To send a glyph of one's world is an act of claiming continuity in an indifferent cosmos. It is to say, in the minimum of strokes, I belonged somewhere, that place mattered. The amplified feeling was not only the ambiguity, technical diligence, and the scale of time governed the public and institutional response. The pictogram reframed what had been an anomalous waveform into a hypothesis with outreach implications and observational protocols. International consortia reallocated telescope time, prioritizing candidate coordinates in the nebula's rim. Archival teams scanned decades of radio and infrared data, using the ratios suggested by the glyph. And theoreticians modeled how a transmitter placed near a nebula edge might exploit plasma lensing to amplify its signal. None of these efforts. There is a philosophical echo in that approach. The act of encoding a pictogram inside a minimalist, durable radio protocol suggests a sender thinking in epochs rather than in instants. To choose dimensionless ratios, primes, and slow frames is to write with things that survive change, basic mathematics, constants of nature, and robust timing. To depict one's planetary system and to emphasize a single planet is to make an invitation that expects patient readers. The question the signal raised, then, is both practical and existential. Who writes to the future? No single decoding could yet resolve that question. The pictogram provided a clue, not a door, but a hinge. It turned a heat map on the rim of a nebula into a candidate address, and it transformed pulses into symbols with intentionality. Whether the emphasized planet would be found in archival maps, revealed by deep integrations, or proved to be a metaphorical device remained open. What was certain was this: the message had shifted from an abstract mathematics lesson into something closer to a conversational gesture. The glyph had invited attention to a place, and attention had the peculiar property of. In the end, the pictograph's gift was to make the cosmic exchange intimate. A few characters arranged as symbolic language, supplemented by a schematic of a system with an extra significant planet, changed the stakes from detection to encounter. Not an encounter of vessels or voices, but an encounter of attention across time. The meeting location hinted at in that small symbol was less a coordinate for fast travel than an axis for sustained inquiry, a place to be examined, to be listened to, and perhaps, in a very long view, to be met. What if the coordinate, offered by the thin sequence of pulses and the schematic pictogram, was not a destination in the sense of a bustling harbour, but a deliberate pointing toward an absence, an empty room in the galaxy chosen precisely because it is empty? That thought is the seed of the first hypothesis about origin. The pulses and the pictographic map are anchored to a coordinate at the margin of stellar population, a point close to the intercluster void between dense star groups. The idea is simple in outline and complex in consequence. An intelligence, at some time in the past, chose the dark borderlands between clusters, the cold, sparse regions where stars are few and the interstellar medium thins, as the site for a marker, a beacon, or a rendezvous. The choice would have been strategic, not sentimental. From the vantage of physics and preservation, the logic is persuasive. In dense neighborhoods, radiation backgrounds are higher, supernova rates are greater, and the probability of catastrophic perturbation, from encounters with other bodies to energetic storms, is non-negligible. In sparsity, structures experience less erosive bombardment from energetic particles. Long-lived mechanical systems face fewer collisions with stray micrometeoroids. Stray signals travel through less turbulent plasma and are less likely to be scattered into incoherence. For an actor that wanted its signal or its monument to inject, technically, choosing a marginal coordinate near a void also simplifies detectability in a different register. A beacon's job is not merely to radiate, it is to be visible against background. A narrowband carrier, set against a sparse background of natural emissions, produces a higher contrast. In the noise budget of a radio receiver, absence is a kind of amplification. The pulse might have been engineered with modest power precisely because it would be heard more easily where the sky was otherwise silent. Such a decision reframes the earlier energy estimates, a transmitter that would be invisible in the cloud. There are at least two distinct flavors to the hypothesis. The first reads the coordinate as the birthplace of the transmission, the place where an active emitter pulses a patient cadence into the galaxy. The second treats the coordinate as a destination, a rendezvous point, a repository, or a marker, a place that contains material evidence, an engineered archive, or an object of significance, and that the pulses merely draw attention to, like a lamp pointing at a landmark. The two are not mutually exclusive. A transmitter can both be a beacon and a pointer to something placed nearby. If the site is an origin, an operating transmitter in the confines of the intercluster void, then certain engineering and survival constraints flow from that ontology. Power is the central problem. Far from a sun that can be harvested easily, a transmitter in a void must rely on local, persistent power sources, long-lived radioactive decay units, banks of isotopic thermoelectric generators, or perhaps slow fusion reactors fed by a small, preserved fuel cache. The engineering ethos required is one of thrift and redundancy. Narrowband transmission, periodic framing, and slow metronomes like the 137-net-second frame already in. Beyond power, stability matters. A near-avoid placement might exploit gravitationally stable pockets, small bodies captured in weak potential wells, co-ed orbital islands where Yarkovsky drifts are slow, or even engineered orbital parking places carved out of contact with major bodies. The stability of placement reduces the need for active station keeping and thus cuts power costs. A transmitter could be anchored to a minor planet or a hard vacuum crater on a captured interstellar rock, one that will remain remarkably unchanged on timescales humans call geological. If, on the other hand, the site is a destination, a repository, or a message in a bottle left in hope rather than expectation of immediate response, the considerations shift toward longevity of information, not immediate radiative prominence. An archive buried in a cold, sparse region can survive erosive processes for far longer than one in an active disk. Materials chosen for their resistance to cosmic ray sputtering, for their resistance to chemical alteration in rarefied gas, and for their ease of remote reading, simple geometric encodings, mechanical markers, dimensionless ratios. Testing this hypothesis is both straightforward and maddeningly dependent on time and resources. The immediate practical steps are observational. The coordinate patch on the sky must be revisited with instruments tuned to the narrow spectral band and temporal framing that the message uses. Long integrations performed by arrays that can synthesize fine angular resolution will seek persistent emission centralized on the coordinate. Is there a point source? Is the source steady, pulsed, or intermittent? If a compact, localized emitter is found, follow-up will estimate proper motion and parallax to determine whether the object is within cislunar distance. Thermal searches, for instance, can reveal hidden artifacts. A structure with active waste heat, even at low power, may produce an infrared excess detectable against a cold backdrop. Submillimeter observations can trace anomalous heating in dust or reveal structures that disturb local molecular lines. Gravimetry and careful analysis of stellar reflex motions in the region could betray a massive body, a planet or dwarf companion that the pictogram emphasized. Of special interest would be coherent, narrow-band signals correlated with a persistent infrared knot. That combination would be. Archive mining is equally critical. The coordinates placement near a nebular rim complicates optical surveys but may leave traces in lower frequencies or in older radio surveys conducted for other reasons. Folding archival radio data with the 172nd framing parameter and the 9-second microcycle increases the chance of recovering marginal captures that were previously dismissed as noise. Cross-temporal coherence, the same structured signal appearing in decade-old data, would be a powerful bit of evidence for persistence. If echoes of the same protocol appear intermittently across the historical record, the weight of the origin reading increases. But there are deeper investigative maneuvers that reach toward the conceptual. Suppose the coordinate points to a small body orbiting in the intercluster margin. If that body carries an engineered companion, a reflector, a passive retroarray, a sculpted surface, then the sky near the coordinate may show unique scattering signatures. Polarimetric studies could detect unusual reflective behavior. Timer-resolved scattering may reveal structured echoes consistent with geometric patterns that correspond to the pictographic glyphs decoded earlier. In short, researchers seek a consistent story. The hypothesis also invites a suite of constraints and counterarguments that must be taken seriously. For one, interstellar propagation effects are treacherous. A signal generated elsewhere can be lensed, focused, or echoed by plasma structures at the rim of a nebula, producing a localized apparent origin that is in fact a secondary effect. The kind of plasma lensing invoked in earlier analysis could plausibly concentrate a remote transmitter's energy into a narrow beam detectable at Earth. In that case, the coordinate might mark the lensing structure rather than the true transmitter. Addressing this possibility requires. Another objection is anthropic. It presupposes a decision-maker whose calculus parallels human intuitions about preservation and visibility. Civilizations that think in different timeframes or with different risk assessments might choose other strategies. Yet even this critique folds back into the hypothesis in a useful way. The messages observed design choices, compressibility, primer-like sequences, slow frames, are themselves universalist design heuristics. They are, in a sense, the least anthropocentric options available. If an intelligence sought memory across time, emotion threads through the hypothesis as well, though not as melodrama. There is a registered psychology in the community that ponders such a sight, a mixture of pragmatic curiosity, institutional caution, and a quiet metaphysical ache. Scientists who had spent nights stacking waveforms, refining decoders, and pruning false positives feel that ache as a professional humility, the sense that they are handling an artifact whose meaning, if confirmed, would recast certain human stories about persistence and loss. There is tenderness in the notion that someone, somewhere, might have chosen emptiness. That emotional register has policy implications. If the coordinate does mark a durable archive or an active transmitter in a scarcely populated region, questions arise about stewardship and reverence. Should humanity respond by sending probes? Should it aim to preserve the site's secrecy, to avoid contamination? Or should it announce its findings widely? Those decisions fold scientific evidence into ethical deliberation. The hypothesis, therefore, is not merely technical. It prescribes a conversation about how to treat possible vestiges of other. Finally, the hypothesis carries with it narratives about the life cycle of societies. A species that buries its memory on the edge of emptiness may have anticipated its own fragility. The choice to place a beacon in a quiet corridor could be defensive, archival, or even ritual. Perhaps it was a waypoint along a sparse migratory route between clusters, a kind of cosmic signpost for travelers moving along low-density roads. Perhaps it was a deliberate archive intended for any who might pass after stellar environments had shifted and once vibrant systems had extinguished. The coordinate becomes a locus where hypothesis 1 is not a tidy conclusion, but a scaffold of tests and consequences. It reframes the earlier decodings, primes, frames, pictographs into a coherent strategy. Choose a quiet place to be heard, economize power and encoding, mark the site with dimensionless ratios and simple images, and rely on the patience of listeners who will, in time, fold their observations into comprehension. The hypothesis demands observational follow-through, targeted radiometry, deep infrared and sub-millimeter searches, archival folding at the discovered framing periods, and careful modeling of plasma. If the tests sustain the hypothesis, the payoff is profound. Confirmation would mean that a durable artifact or transmitter exists in the galaxy's borderlands, a humanly comprehensible index of intentionality cast into a region chosen for its silence. If the tests fail, the hypothesis still contributes, it sharpens methods, defines priorities for deep-time archaeology, and forces the scientific community to articulate why emptiness might be chosen as a medium for memory. Either way, the thought experiment insists on a new posture toward cosmic artifacts and attention to marginal places in the tense hush that follows the discovery of a patterned whisper. Imagining a coordinate as a marker in the void is not a romanticization, but a practical hypothesis. It is a map of expectations and a program of observations. It treats silence as a resource and emptiness as an intentional canvas. Whether the coordinate is the site of a powered transmitter, a slow beacon waiting in the dark, or a hollowed-out memory place intended for archaeologists of the far future, the hypothesis gives form to a question that reaches beyond immediate detection. It asks what would a warning sound like if it had to cross epochs? The thought arrived not as a revelation, but as a logical inversion. Until now, the pulses had read like a patient, pedagogical transmission, primes and frames, pictograms that looked like maps. What if those same design choices had another aim besides introduction and identity? What if the compact protocol, the slow 170-second framing, and the emphasized planetary glyph were not an invitation so much as an alarm bell set to toll across deep time? The hypothesis was, in its skeletal form, an economy of urgency. A transmitter that wished to be understood by strangers across generations might first teach them how to count, then show them a diagram of its world, and finally annotate that diagram with a simple, unmistakable mark, a hazard, a trajectory, a direction to avoid. In this reading, the emphasis on a single planet could be not a boast of home, but a pointing finger. The primes taught the listener that they shared a capacity for abstraction. The pictogram located a system in invariant ratios. The slow frame gave the listener the template. Evidence folded into the hypothesis in subtle, accumulating ways. Quantitatively, the most arresting fact was not any symbolic passing, but a practical one. The carrier's strength diminished day by day. In the beginning, the amplitude was a faint but steady ember against background noise. In later captures, that ember dimmed in a trend more consistent with an exponential decay than with random fluctuation. Instrument teams applied conservative statistical tests. Cross-checks were exhaustive. Housekeeping logs verified clock stability. Independent receivers compared gains. Archival calibrators were A loss of power has many faces. It can be a battery drained by time, an energy source exhausted by age, or a system compromised by catastrophic environmental change. The very kinds of catastrophes a transmitter might be built to announce. The alternative explanation, that intervening plasma or dust was thickening and thereby absorbing the carrier, carried different predictions. An increase in scattering would broaden pulses, smear their edges, and introduce characteristic frequency-dependent delays. The observed waveform, however, became quieter, not blurrier. The pulses preserved that technical pattern opened further interpretive doors. If the emitter's power was being lost, why? One possibility was the prosaic and engineering failure in an old power system, the inevitable decay of radioisotope generators, the corrosion of circuits from cosmic rays. Another, darker possibility was a local calamity. A star in the system had destabilized, a shock front from a nearby supernova was approaching, or an impactor. A cometary body or rogue object was about to intersect the emphasized planet's orbit, rendering existence there dangerous. Under the warning, the community of listeners responded with that mixture of calm protocol and inwardly sharpened urgency that such possibilities elicit. Observational resources were reprioritized. Where before the signal had been a long-term curiosity, it now required rapid, cross-disciplinary mobilization. Radio arrays tuned to the narrow carrier, infrared observatories searching for unexpected thermal anomalies in the candidate coordinates, spectral line studies to look for signatures of ionization or shock heating in the surrounding nebula rim. The archival hunts acquired urgency not because the past would change. Those practical steps were accompanied by a different kind of labor, less measurable but equally intense. The message's interpreters found themselves applying the humanity's slow instruments, thought experiments, scenario projections, and ethical framings, alongside the analytics of signal processing. The warning hypothesis forced a rehearsal of questions. If an extraterrestrial civilization had recognized a danger and chosen to erect a durable alarm, what kinds of events would it choose to announce? Would it warn distant others of a catastrophe that did not affect them? Would it send a message meant to protect neighbors? Or would a key nuance complicated matters? The candidate source lay thousands of light years away. A warning about a local disaster, a collision, a planetary magnetospheric failure, a nearby supernova would reach Earth only as evidence of someone's last act, not as a practical protection for humans. That realization restrained immediate panic. But the cultural weight of being witness to another intelligence's final warning was itself enormous. The act of sending, the choice of format, the decision to sacrifice dwindling energy to reach a stranger, these were gestures that are Still, caution was not the same as paralysis. Scientists posited observable signatures that could either corroborate or undermine the warning reading. If the transmitter was failing because an energetic event had occurred locally, there should be local environmental evidence, increased dispersion measures from ionized gas around the source, emerging infrared excess from dust heated by a shock, changes in molecular line ratios suggestive of recent heating, or, for the most dramatic cases, a new brightening in high-energy bands consistent with a stellar explosion. If instead the transmitter's power source had simply run down, none of these signatures would appear. In practical terms, this meant telescopes were tasked to scan with urgency and patience. Arrays that had been scheduled for months were reprioritized to take long, coherent integrations over the candidate coordinates. Spectrographs hunted for line broadenings and non-thermal emission. Polarimeters scrutinized changes in polarization that might indicate evolving plasma conditions. The 1370L second frame that had once been an elegant curiosity now served as temporal leverage. By folding noisy captures on that slow period, analysts increased effective sensitivity and could pursue marginal environmental signals that would otherwise remain parallel to the technical campaign. A policy conversation unfolded, disciplined and somber. Disclosure choices are rarely merely public relations problems, they are ethical ones. Releasing a preliminary interpretation that the signal was a warning and that its source was dying could set off a cascade of social and political effects. It might trigger wonder and empathy, or it might incite fear and superstition. Conversely, withholding the finding until greater certainty was achieved risked accusations of secrecy and paternalism. The institution stewarding the data performed a familiar. That bureaucratic restraint did not diminish the emotional charge. Observers, described more as a community than as individuals, reported a constriction of attention, a sense that the sky had become a room in which someone was breathing their last. In the server rooms, LED panels reflected across glass and metal like constellations. In the scheduling centers, calendar slots were shuffled as if moving pieces around a board. The work became a kind of vigil. Repeated captures were saved, metadata annotated with particular care, and every new marginal hour of signal strengthened or weakened. Interpretive care yielded hypotheses that could be operationalized. If the transmitter's fading was due to a catastrophic event localized to its system, then archival data might reveal a slow prelude, small shocks, rising maser activity, incremental increases in local ionization detectable in certain molecular traces. If the evidence for environmental change accumulated, the narrative would shift from witness to evidence of universal fragility. Civilizations, like stars, have life cycles and endings, and sometimes they send notes into the dark as their last act. If no environmental evidence emerged, the narrative would fade. The choice between these readings mattered for how humans responded. For cultural historians and ethicists, either reading carried profound implications. A warning would illustrate an alien concern for potential others. A testament would illuminate a civilizational choreography for endurance. For astronomers, the difference mattered in resource allocation. A confirmed environmental catastrophe would invite deeper, multi-year wavelength monitoring in hopes of learning about stellar death, planetary survival, or the resilience of techno-signatures. For the public, the distinction colored the emotional tenor. Days passed. The decay in amplitude continued to be measurable, and each measurement carried with it a small narrative cost. As the signal fell, some decoding possibilities faded with it. High frequency microstructure, already marginal, shrank below detection thresholds, complicating efforts to extract more symbolics. That loss was a bitter irony. If the transmitter were indeed issuing a warning that required complex details, those details might never be recoverable. The message, perhaps deliberately minimal to maximize survivability, was slipping toward its simplest legible features. The community of stewards therefore adopted a dual posture: accelerate observation now, because the signal was weakening, and preserve, with scrupulous redundancy, everything collected. Raw IQ samples were copied to multiple archives. cryptographic hashes recorded, and provenance logs made immutable. The data became a shared cultural artifact, entrusted to interlocking repositories because the message's fragility demanded care, as if dealing with a fresco on the verge of crumbling. In quieter moments, the broader implications of the warning hypothesis settled into a reflective tone. Whether the pulses represented a dying transmitter sending instructions, a civilization's last attempt to point to a hazard, or an act of remembrance, the scene invoked a particular human feeling, smallness faced not only with wonder but with a kindred recognition of impermanence. The idea that another intelligence might have foreseen collapse and chosen to speak anyway resonates with human practices of funerary inscription, of last words scrawled by hands that know the time is short. The act of transmitting a warning or a testament. By the end of the first intensive week, the signal's decline was statistically robust. The community's attention had shifted into a new mode, triage. Some teams focused on environmental corroboration, searching for spectral footprints at the nebula rim. Others continued to squeeze every possible bit of structure from the fading carrier, building stacked templates and testing error-correcting decoders that might reconstruct degraded microstructure. Still others prepared the institutional scaffolding for transparency, communication plans, educational materials, archival protocols. The work was technical. The signal, for its part, kept a steady metronome of 9-second beats within its now weaker frames. Fading did not necessarily mean silence tomorrow, it meant that every hour of listening counted more. If the transmitter was a dying voice and its message a warning, then the shrinking amplitude was the most urgent argument of all. Listen now, because the sender may be running out of time. The watchers listened. They counted. They folded and stacked. They debated release strategies and tested environmental models. Outside the laboratories, broader human conversations took shape about memory, about obligations to other intelligences, and about what it means to witness another species' last act. The hypothesis that the pulses were a warning remained one among several, but it was now a live one. It demanded surveillance not only as science, but as a moral attention. In the face of deep time, the act of heeding is almost as meaningful as the act of sending. Time, in that moment, pressed both ways, on the transmitter, whose signal dwindled, and on the listeners, whose interpretive window narrowed. The pressure was not merely technical, it was existential. What would humanity do with the fragments of a message that might be the last testament of a civilization? The question hung as the pulse, weakened but persistent, stitched itself into the continuum of night and instrument hum, a small, deliberate insistence in the vast silence that invited reply, or at least bearing witness. The choice to watch, to archive, and to think became the human. If the signal was dying, then time had suddenly acquired an edge, a phenomenon that had at first insinuated itself into the quiet disciplines of measurement. Nested primes, a 37-second frame, a spare pictogram pointing to an emphasized planet on the rim of a nebula, now demanded a decision that was not only epistemic but operational. The facts on the waterfall plot had been steadily recast by a single, unsettling statistic, an apparent decline in emitted power that persisted after the most conservative cross-checks. The decline was small at first, then cumulative. That is how the idea of a survey mission moved from footnote to programmatic possibility. In offices and laboratories around the world, in the margins between observatory scheduling and international law committees, the question posed itself in a different register. Could a craft be sent in time to document, to sample, or to witness? The question was not rhetorical. It cut across technical capacities, legal frameworks, ethical norms, and the brittle psychology of institutions asked to respond when evidence suggests the ephemeral. The simplest urgency was logistic. A mission is a choreography of resources, launch vehicles, telescopes for navigation, bandwidth for telemetry, instruments tuned to a narrow carrier, and, crucially, time. Even a probe designed for the near term must be conceived, built, tested, and launched. A process measured in months rather than days. Faced with a dimming carrier, planners asked whether there were faster options, opportunistic piggybacks on scheduled launches, rapid deployment of small satellites to cislunar staging points, or the creative repurposing of existing assets. Radio telescopes pointed in novel mosaics, arrays. That pragmatic calculus, however, collided with a different set of concerns: risk. The risk spoke in many tongues. There was the technological risk that a probe approaching an unknown transmitter might be harmed by the very physical processes that had given birth to the signal: intense localized fields, coherent beams, charged particle flows from a disturbed plasma, or focused radiation that could fry electronics. There was a contamination risk, the worry that a visiting human artifact, even an automated one, could irreversibly alter a site that might be archaeological in nature, erasing material evidence that would otherwise remain interpreted. Institutions responded in the only way institutions can, by staging a debate. The debate had structure. Technical briefs presented the spectrographic evidence and power trend lines. Legal analysts read sections of the Outer Space Treaty and Planetary Protection Guidelines, insisting on obligations of non-harm. Ethicists reminded the community of obligations to unknown others, to protect sites that may be monuments rather than mere objects. Defense planners offered risk assessments of dual-use scenarios, and public affairs units worried about the social aftermath of any choice. The central voices in the argument clustered around two poles. One cluster argued for haste: send something now, because the signal was a finite window into a possible monument, an answering card from the deep that might vanish with the waning amplitude. The immediate priorities here were evidence preservation and retrieval. In that practical register, the mission could be limited and conservative: a probe designed not to touch but to look closely, to use standoff sensors to record higher fidelity spectral and polarimetric data, to image any structure at scales permitted by proximity, and to record environmental parameters. Opposing that urgency were voices of restraint and caution. They enumerated scenarios in which approach itself could be a provocation. One risk was contamination in the literal sense. A probe could deposit terrestrial microbes or chemical residues that would compromise the very signatures researchers sought to study. The other risk was hazard in the physical sense. The transmitter might be failing precisely because its environment had become unstable: a region of ionized gas, a cloud of energetic particles, an actively collapsing structure. Worse, it could interact with the site in unforeseen ways, altering the behavior of a delicate apparatus. And then, embedded in both pragmatic and principled arguments, was a further, subtler tension: how to be a steward rather than a colonizer. A message characterized by pedagogical arithmetic and durable framing invites a careful reply. If the signal was indeed intended as a legacy, then the appropriate human response demanded humility. Approaching a place that might be a grave, a library, or a warning requires methodologies more akin to archaeology and conservation than to retrieval. That realization reshaped mission design preferences toward minimalism, passive observation. Those design preferences had practical implications. A mission intended to preserve rather than to possess demands different instruments. Imaging systems would prioritize wide dynamic range and low light sensitivity to capture faint structures against a cold backdrop. Spectrometers would be chosen for high spectral resolution and stability over raw bandwidth, on the logic that subtle line shapes would betray engineered materials. Dust analyzers would be capable of in situ, non-invasive sensing, capable of deducing compositional clues from scattered light rather than returning physical grains. Yet even that conservative, almost reverential approach had an uncomfortable cost: time. The longer it takes to craft a suitably careful mission, the more likely the signal would fade into silence. The declining amplitude itself functioned rhetorically like a timer, converting what had been debate into triage. Rapid lower-impact steps could be taken immediately: reposition existing radio arrays into synthetic apertures, direct infrared and submillimeter telescopes at the heat equivalents of the glyph's coordinates, repurpose available satellites to act as listening posts, and deploy a swarm of CubeSat Another dimension of risk was not physical, but epistemic. Approaching a site with intrusive instrumentation threatens the interpretive integrity of the evidence. Archaeologists know that excavation, even when conducted meticulously, reconfigures context irrevocably. The act of touching a relic is not only a means of knowing, but also an act of transformation. The same is true for extraterrestrial artifacts. Instruments that scrape a surface, that disturb local fields, or that move objects change the very system that analysts seek to read. If the transmitter was a designed archive or a warning marker these competing logics folded into international frameworks in concrete ways. The Outer Space Treaty and accompanying protocols do not address every contingency, but they do set a tone. Celestial bodies are not the province of single nations, and activities must be undertaken with due regard to the interests of all humanity. Planetary protection norms, developed to prevent forward and backward contamination in the context of Mars and icy moons, were stretched into uncharted territory when asked how to treat a possible extraterrestrial archive. The legalistic debate thus over economic and political pressures did not simplify the picture. Funding agencies are responsive to public interest, a compelling narrative of imminent loss drives, headlines, public donations, and political capital. Conversely, military actors might see strategic opportunity in a novel site. Telemetry data could be militarily useful, and the capabilities developed to reach a distant coordinate. High-precision navigation, autonomous decisioning in harsh environments have dual application. The debate therefore assumed geopolitical overtones. There were proposals that the mission be a multinational enterprise. Amid these institutional complexities, there was a quieter, human current, an ethical sense of obligation. Many who reflected on the problem did so, not as administrators of capability, but as custodians of a fragile conversation across time. The signal, whatever its origin, had initiated a relation. To be the first to physically intrude upon its locus required the humility of caretakers. The idea of stewardship framed proposals for oversight councils, scientific peer review, and an international registry that would document every keystroke of mission design. The practical compromises emerged. The architecture of response bifurcated into two streams: immediate, reversible interventions designed to record and preserve, and longer-term in situ operations that would be undertaken only under stringent, internationally ratified protocols. Immediate options included targeted reanalysis of archival data folded with the known framing parameters, concentrated radio campaigns that would not physically approach but would refine localization, and deployment of listening arrays in space at distances that maximized resolution without risking physical interaction. A particularly delicate issue concerned the possibility that the transmitter was not static but mobile, that the apparent decline in power was not death but departure. If the emitter were lifting off, fleeing, or reconfiguring itself to become undetectable, then the calculus shifted again. Landing to investigate a dynamic system could prove futile. The priority would instead be to track and document motion, to determine trajectories and velocities, and to search for patterns that might reveal intent in departure. Tracking a moving emitter presents its own hazards. Pursuit might be misread by unseen guardians, while misinterpretation of motion. Ethical arguments did not always resolve conflicts of interest. Some pointed to the moral imperative of curiosity. If a message embodied traces of cognition beyond Earth, the ethical obligation to learn could be construed as paramount. Others countered by elevating the obligations owed to the sender in absentia or extant to have its property and context preserved. Those debates were not purely academic. They had to be translated into rules of engagement, into hard engineering specs that would constrain fuel loads, sensor suites, and operational parameters. Converting ethics into hardware. In the trough between options, the practicalities of an initial mission were sketched with meticulous conservatism. A reconnaissance craft, it was proposed, should be sterile to the greatest practical degree, fitted for standoff radiometry and high-resolution polarimetry. capable of forming synthetic apertures with Earth-based arrays to synthesize imaging baselines without having to approach dangerously close. Its autonomy should be conservative, systems that will abandon approach in the face of any anomalous field strengths, thermal excursions, or particulate encounters. The craft's communication plan should prioritize. These technical counterweights were reconciled in committee rooms, in the margins of policy papers, and across channels that looped security analysts with planetary scientists. The debates were long because their outcomes would define not only a mission, but a precedent. How humanity chose to approach this particular locus, with care or with haste, with stationing of instruments or with physical excavation, would be read as a template in future encounters. The layers of consequence were not merely immediate, they were meta-ethical. The world was determining how it wished to comport itself toward possible others and their traces. Public sentiment tightened the pressure. Media narratives moved between awe and admonition, between nostalgic romanticism and practical concern. Social movements demanded transparency and insisted that any mission not be commandeered for secretive military ends. Others urged swift action, seeing procrastination as moral failure. The political calculus, then, measured both the probability of scientific loss and the risk of poor governance. In the end, the decision would not be purely scientific, it would be a negotiated social act. When the choice crystallized, it was not the triumph of a single argument, but a compromise shaped by risk, resource, and principle. The first tranche of activity would be an accelerated program of remote reconnaissance and distributed, sterilized listening posts, an attempt to preserve as much of the signal's nuance as possible while buying time to prepare any eventual in situ mission under internationally agreed standards. The program would be governed by a coalition charter embedding non-interference rules and open data policies. Red teams would be tasked with stress testing contamination scenarios. Ethicists would be embedded in. The debate had been taxing because it forced a species to articulate what it valued: raw knowledge, the sanctity of an other's material legacy, safety, or the prestige of being first. The arguments that emerged were practical and philosophical in equal measure, and they were guided by a single sober principle that unites many disciplines: humility before the unknown. In the end, humility does not paralyze, it constrains. It asks for precautions that steward evidence, for governance that respects multiple stakeholders, and for technologies that prefer listening to touching. The signal continued to tick in the background, its 9-second heartbeat and 30-second frame compressing meaning into slender intermittence. The measured decline in amplitude remained, a fact to which the world had to respond with both patience and speed. The decision to send a survey asset before the signal disappeared did not resolve all questions. It created a plan that balanced urgency and restraint, curiosity and caution. The Great Debate had not produced certainty, it had produced a protocol, a way to act that acknowledged the fragility of evidence, the risk of harm, and the moral obligations owed to potential others. It was the smallest, most. What does it mean? In a species of finite attention spans and limitless curiosity, to choose motion as the answer to a question asked across epochs. The decision to send a machine was not a single heroic moment, but a procession of small, deliberate acts, proposals, red teams, sterile lists, legal memos, and midnight runs of simulation code. It was the pragmatic translation of a moral intuition, that a patterned whisper from the dark deserved not only witness, but careful reciprocation, into hardware and rules. In that translation lay the paradox. The world had been trying to resolve for weeks how to be both curious and modest, how to move toward evidence without consuming. The final decision was the product of a broad and unusual consensus. Governments, research institutions, and non-governmental stewards had formed a charter to govern the response, a multinational coalition with open data commitments, sterilization mandates, and a tight principle of non-contact. That charter refused the romance of immediacy. It refused, as well, the temptation of speculative haste. What emerged was a compromise that reflected the tensions of the moment, a dual track of action. On one side, a distributed network of listening posts and orbital listening clusters would be deployed within weeks. Design choices bore the imprint of those values. The reconnaissance craft, when the plans were finally summarized in a dry, exacting mission brief, was described as an emissary of attention rather than a harvester of artifacts. The payload suite read like an archaeologist's wish list translated into electronics, ultra-high spectral resolution radiometers tuned to the narrow carrier, broadband polarimeters to map the fine structure of polarization that might betray engineered surfaces, infrared arrays for low-level waste heat detection, and sub-millimeter spectrometers to resolve molecular traces indicative of recent activity. Imaging systems emphasized sterilization protocols were exhaustive and, at times, mind-numbingly procedural. The mission team under the Coalition's governance adopted the most conservative planetary protection standards available, then extended them. Clean rooms treated hardware like relics, multiple stages of dry heat sterilization, hydrogen peroxide vapor cleaning for enclosures, ultraviolet bakeouts for non-heat tolerant components, and bioindicator testing at every step. The logic was simple and absolute. Do not let a terrestrial microbe stand in the way of interpreting a message not of this soil. But sterilization is never only. Equally important were the operational rules embedded in the craft's autonomy. The light time to the nebula rim precluded micromanaged remote control. The vehicle therefore carried conservative, layered autonomy dictated by immutable policy: never physically alter a site, never deploy a probe or tether without explicit multi-party authorization. And, if anomalous high-energy fields or particulate hazards were detected, retreat to a prescribed standoff distance. These were not mere engineering constraints, they were institutionalized humility encoded into silicon. The proposition was that the mission architecture was a study in trade-offs. Time pressed from one side, the carrier's apparent decline, the risk of losing microstructure, and prudence from the other. To reconcile them, the Coalition adopted a layered launch strategy. First, existing assets would be repurposed. Radio telescopes would form dense virtual apertures, arrays in different hemispheres would synchronize observations, and scheduled launches would carry small listening CubeSats to high Earth orbit to increase parallax baselines. Second, a central reconnaissance craft would be built on commercial. Even as engineers sketched thruster budgets and thermal envelopes, ethicists and policymakers continued to refine the rules of engagement. A standing multinational council was established to adjudicate any decision that would alter the site's material context. That council's charter mandated transparency, irreversible declaration of steps taken, and a clear burden of proof before any invasive action could be authorized. In practice, this meant that the first craft was explicitly forbidden to touch. It would only observe, record, and broadcast raw, unedited data to multiple independent. Launch day, when it came, was not an act of drama, but of choreography. Rosettes of protocols were executed in series, last-minute leak checks, a final cavity UV pass, and instruments moved into a flight-safe state. The craft's telemetry included an immutable provenance log, a cryptographic record of every action taken, so that future analysts could verify that nothing had been done without consensus. The launch vehicle's ascent was quietly efficient. The orbiters that had been deployed earlier, the listening swarm, were scattered into strategic points of parallax and into cislunar staging locations to stand ready as relay, and as the vehicle distanced itself from Earth and the immediate noise of human infrastructure, the species' collective attention stretched into new registers. The press of governance and the hum of servers were replaced, in public discourse, by a more contemplative mood. The mission became a story not about conquest, but about bearing witness. Commentaries swelled into philosophical essays and quiet think pieces, meditations on how to treat the remains of others, thought pieces about human hubris, and sober columns reminding the public that patient listening is itself an ethical act. Religious and cultural. The voyage itself was a lesson in cosmic temporality. propulsion burns were measured against an arithmetic of patience. Trajectory planners optimized for both energy efficiency and observational opportunity, inserting Earth gravity assists and extended coasting phases to conserve power for the craft's instruments once it reached the target zone. En route, the mission's data products were not spectacle but substance, refined spectral templates, polarization catalogs, and increasingly precise parallax measurements that tightened the heat map of the possible locus. The listening swarm in high orbit provided those deviations produced a new layer of interpretive care. Tiny, systematic timing offsets suggested that the emitter, if it was indeed a transmitter, might have been compensating for orbital motion, or that it was regulated by a failing power management system. The reconnaissance craft's instruments were calibrated against the listening array's data. Their cross-correlation pipelines were forged as an act of epistemic rigor. Every data product sent home was accompanied by provenance metadata and a history of the algorithms used to derive it. The coalition insisted upon approach protocols with the most delicate choreography. The craft's sensors were tuned to a watchful, non-invasive approach. At long-range, synthetic aperture radio imaging would seek a compact source. At intermediate ranges, polarimetry and infrared radiometry would test for localized thermal anomalies, and at the closest standoff still many kilometers away, low-energy LiDAR would map surface roughness and topography. The mission plan explicitly forbade any propulsion action that would alter the target's environment. Even the act of illuminating the site with active radar was to be approached cautiously. Low power, data returned in slow, steady drips. The light time delay rendered the mission's narrative into a patient correspondence. Measured telemetry arrived, was verified, archived, and distributed to the coalition's distributed repositories. Each packet was transcribed into multiple formats for redundancy. Checksum chains made the data trail auditable for decades. When the first high-resolution radio image synthesized by the network appeared, it was not cinematic. It was shades and contrasts, a hum of organized noise against a darker field. Analysts, working under explicit non-dramatic protocols, annotated structures in new. The public, however, could not help but read stories into shapes. That, too, was part of the decision the coalition had made, to manage not only the science but the social meaning of the mission. The coalition released images, but only with careful contextual briefs explaining margins of error and the provisional nature of any interpretation. The desire was to reduce the risk of premature conclusions, to preserve interpretive humility as a civic value. Yet even with all of that, the images carried a weight beyond data. In the pale gradations of brightness and the arrangement of contrasts, many saw ethically, the mission was a continuous exercise in restraint. Encounter protocols required repeated checks before any new instrument mode could be enabled. Every decision was logged and published. The craft's first months in proximity were dominated by passive observation and by attempts to reconstruct whatever had produced the original pulses without changing the target environment. These cautious choices were not mere caution for caution's sake, they were a moral posture. If the message was a tombstone carved in electromagnetic ink, its meaning could be erased faster by eager hands than by. Yet even restraint carried unanticipated burdens. The very rules designed to prevent harm sometimes limited the ability to answer pressing scientific questions. Some analyses requested higher signal levels for active probing that might have provided clearer compositional diagnoses. Others argued that passive observation risked leaving crucial hypotheses untestable. Those tensions surfaced in committee hearings and in the quiet annotations of technical reports. They were not resolved in single pronouncements but negotiated continuously in the margins of meetings and memos as the world learned what it means to stew. Throughout the reconnaissance phase, the mission produced moments that were small, precise, and oddly human in their affect. A new spectral line resolved. A polarimetric mapping suggested the presence of filamentary surfaces with high reflectivity. A stacked fold of frames revealed a recurrence of the pictographic motifs ratios in the geometry of the compact source. Each increment of evidence moved probability weights, not certainties, and each increment also produced an emotional cadence among the attentive, cautious elation, a somber wonder, the soft ache of things both distinct. At the same time, public institutions confronted unanticipated civic work. Schools created curricula around the mission's ethics. Museums staged exhibits that paired technical visualizations with meditations on stewardship. International forums debated a charter for future such encounters. The mission, beyond its scientific remit, became a collective exercise in how a global society coordinates curiosity. The conversations ranged from the pragmatic how to fund long-duration stewardship to the philosophical. What obligations does one generation have to the material legacy of another, even when, after months of careful approach, the reconnaissance craft's instruments assembled a composite that correlated the earlier radio pulses with spatially resolved features, the coalition did not speak in exultation. Instead, it restated limits, published uncertainties, and highlighted the open questions that new data had generated. The findings were significant in probabilistic terms, but not conclusive in a hermeneutic sense. That ambiguity was, perhaps, the mission's most important result. It demonstrated how meaningful restraint could be operationalized in practice and how a world, in the end, the launch and the long, measured approach were less about the moment of arrival than about the kind of attention humanity chose to bring to it. The craft did what it was built to do. It observed without touching, it recorded without erasing, and it returned a slow, careful stream of data that enabled the species to translate astonishment into inquiry. Whether or not the site proved to be an active transmitter, an engineered archive, or an intricate natural mirage created by the interstellar medium mattered less than the precedents. That choice echoed in quiet ways. Citizen scientists continued to fold archive data for echoes. Ethicists drafted stewardship codes for instruments and artifacts beyond Earth. Instrument designers re-evaluated sterile design practices for future missions. The mission's story had become, in a sense, the public's exercise in deep time, an attempt to act in a register larger than political cycles and human impatience, to orient toward a future audience with the deliberation that memory itself demands. The reconnaissance craft moved on, its datasets growing into a public trove. The pulses that had summoned attention kept their steady cadence in archived files, 9-second heartbeats nested inside broad, slow frames. The world listened, and in listening it made a promise to look, to learn, and to care. The final decision, chosen by many hands, argued with prudence, executed with technical mastery, was not an end so much as a commitment. It was an admission of smallness before the deep timelines of the cosmos, and an affirmation that, even so, attention is a kind of fidelity, a way. What happens when the listening becomes doing? The transition from passive vigilance to directed approach is less a cinematic leap and more an accumulation of small, deliberate motions, commands cued, thrusters sparked, long arcs of trajectory nudged into alignment, and the choreography of instruments reoriented from patient receivers to active surveyors. The reconnaissance vehicle, assembled under the coalition's austere rules and dispatched with the express purpose of observing without disturbing, entered that choreography like a single note in an orchestral movement. Its propulsion was unremarkable in engineering terms. Its significance lay as the craft executed its final burns and closed distance. Something that had been only an acoustic promise on spectral plots changed its modality. The narrowband carrier, which hitherto had been a thin, patient thread threading the sky, began to register with greater amplitude across an expanding suite of receivers. The increase was not explosive. It was the kind of signal growth consistent with proximity, a slow rise in flux density, subtle changes in spectral flatness, a diminution of background noise as the craft's relative geometry improved the effective aperture of the receiving system. But it was also the kind of rise that had a rhetorical effect. High-resolution multiband imaging techniques were brought to bear with the patient proceduralism that had characterized the earlier phases. The reconnaissance craft operated as an extension of the listening swarm. Its radiometers folded with ground arrays to synthesize larger baselines. Its polarimeters contributed crucial vectors to map field geometry, and its infrared sensors scanned for thermal excesses that might betray waste heat or recent energetic activity. Every sample transmitted home was accompanied by the coalition's provenance logs, immutable chains that ensured the integrity of the record. The most immediate sensory impression in the data was a sharpening of the carrier's spectral character. What had been a narrow, clean line in early captures now showed features, fine notches, micro sidebands, and phase coherence across enough bandwidth to suggest a structured source rather than a simple natural maser. Polarimetric measurements, in particular, offered unexpected clues. The emission showed a high degree of linear polarization that changed predictably across pulses. That coherence argued against chaotic scattering by turbulent plasma and argued for either engineered antennas with a preferred orientation or materials that imposed. Imaging told story, stacked radio maps, synthesized from the spacecraft's instrument suite and the distributed listening array on Earth, resolved a faint, diffuse source in the expected heat map island. Its morphology was at first generous with ambiguity. The object appeared as an extended brightness with internal asymmetry, a dim halo punctuated by a brighter, elongated core. As integration time lengthened and baselines widened, the halo collapsed into contours that hinted at structure, radial striations, planetary tails, or thermal dust clouds. When infrared overlays were applied, the thermal signature was surprisingly low. Too cold for an obviously active industrial. The first impression most teams communicated, always carefully hedged, always accompanied by methodological footnotes, was that of scale. The blurred image corresponded to a structure of enormous lateral extent. Even allowing for parallax uncertainties and for the vagaries of synthetic aperture reconstruction at the significant light-time distances involved, the elongation suggested a construct that could span hundreds, perhaps thousands of kilometers. That scale transforms questions of origin into questions of persistence. Structures that big cannot be ephemeral. Dust agglomerations in a tenuous medium, they demand either. Still, the data were careful to withhold certainty. The object's reflectivity pattern bore resonances of both material and geometry. Certain lobes showed metallic-like reflectivity, others scattered like dielectric membranes. The polarization pattern cycled in a way consistent with arrays of anisotropic panels, thin faces oriented at varying angles to a central axis, interleaved with hollow, low emissivity corridors. Spectral analysis of scattered light in the submillimeter suggested the presence of surfaces with low emissivity and high specular components, materials engineered to reflect rather than radiate. What such a structure might be is a matter of disciplined speculation. The data allowed a set of constrained archetypes rather than a single narrative. A library, an engineered repository meant to persist in a quiet region, a signal source, a transmitter unit embedded in a larger passive architecture that amplified or shaped emissions, a transit platform, perhaps an interstellar arc or transfer shell, or, more provocatively, a boundary object, a gate-like arrangement that alters space in ways not yet fully understood. None of these archetypes had full. As observational confidence grew, so did the emotional tenor among the human stewards. Throughout the campaign, that tenor had been calibrated by protocols, legal frameworks, and public commitments. It had been intentionally unspectacular. Yet data have a way of making the austere into the intimate. In laboratories and in sleeves of international meetings, the community experienced a familiar convergence, wonder laced with caution, the thin ache of humility, and an emergent sense of responsibility. The object was no longer merely an explanation puzzle, it was an artifact occupying space, a locus of possible meaning. Among the technical subtleties that the approaching craft revealed, one stood out for its eerie resonance with the earlier decoded elements of the signal. The reconstructed morphology displayed repeating modular units, geometric motifs that recurred at multiple scales, each module bearing a coarse symmetry. Viewed at the scale of the entire object, the modules arrayed along radial patterns that suggested deliberate layout rather than chaotic assembly. When analysts applied the same folding techniques that had made the under 30-second framing and the primary-like sequences intelligible in the radio domain, temporal folding raised the possibility that the structure was both the source of the pulses and an encoded map, an artifact designed to be discovered by attention rather than by force, moved from speculative footnote to central working hypothesis. It was a convergent story, a compact transmitter embedded in a larger, low-emissivity construct placed at a quiet coordinate, optimized for longevity and for detection by receivers that could count and fold. If the hypothesis held, then what the reconnaissance mission had found was not merely a transmitter, but a designed locus of memory. An engineered object. That realization reframed the practical question the coalition had been preparing for since the first detections: how to proceed now that an object with such architecture had been observed at distance. The answer was not aggressive. The Charter's conservative ethics shaped the next steps. The reconnaissance craft entered a measured standoff trajectory, optimized to minimize the risk of material contamination and perturbation. It continued to collect low-impact data, ultra-stable spectral runs to resolve subfeatures, polarimetric mosaics to map anisotropy, and delayed encrypted data dumps to multiple archives to ensure that no single. The larger, public dimension of the encounter also began to change. What had been an abstract debate about the ethics of approach became a philosophical conversation about thresholds. The structure's scale and its architectural hints posed a question not only of how to act, but of whether humanity was ready to interpret and to be interpreted. The object's existence altered the philosophical grammar of contact. The problem was not simply, are we alone, but how do we answer when the thing that proves otherwise is designed to be found by patience and humility? The public discourse, civil society, scholars, and even as institutions deliberated, thought experiments multiplied. One scenario treated the object as a doorway in a literal engineering sense, a construct that, when properly engaged, might reveal internal geometries or field configurations, enabling access to stored materials or informational caches. Another treated it as a monument, an enduring archive whose significance lay not in interactivity but in being read carefully. A third, more cautious scenario considered the possibility of an intentionally defensive object designed to. The reconnaissance craft's findings did not close any of those possibilities. Instead, they opened a narrower, clearer aperture for future work. The composite image, the polarization maps, and the modular ratios provided testable predictions, particular spectral lines that would reveal synthetic materials if present, polarization phase behavior that would indicate engineered reflection versus natural anisotropy, and the presence or absence of localized thermal anomalies that would distinguish active systems from inert monuments. Those predictions could be operationalized without immediate physical intervention. If there was a single affective hue that the moment added to the campaign, it was an intensified humility. The object in the quiet of interstellar margin seemed to ask something that physics and philosophy often forget to ask: what is the right pace of understanding? The signal that had first insisted on attention had become a structure that insisted on guardianship. That insistence required a kind of patience, measured not in launch windows or funding cycles, but in the slower currencies of stewardship, careful observation, international consent, methodological rigor, and the door the coalition had feared and hoped for was not a portal that would open with a single key. It was an aperture in the human story, a threshold where listening had become seeing, and where seeing demanded a moral response. The structure's approachability in physical terms did not render it approachable in ethical terms. The prospect of closer access, the temptation to reach, to sample, to take, was tempered by the knowledge that any interaction would be transformative, not only for the artifact, but for those who made the choice to touch it. To alter that which spoke to endurance would be to assert a future. In the end, the reconnaissance phase ended less with a revelation than with a commitment. The community had received a more detailed impression of an enormous structure drifting in quiet space, an object whose spectral, polarimetric and morphological signatures suggested deliberate arrangement and whose architectural grammar echoed the earlier message. That conjunction upgraded probability but did not collapse doubt. The coalition therefore articulated a plan that preserved the object's integrity while extracting maximum understanding, continued standoff observation. The door, in the documentaries language, was not being opened by force. It was being acknowledged as a threshold that required patience, reverence, and shared responsibility. The structure's faint, increasing song had become an invitation to learn how to answer. The answer would not be a single act, it would be a slow, careful choreography of seeing, recording, and refusing the quick satisfactions of conquest. In the weeks that followed, the data would thicken, the debates would deepen, and the human project of being a steward of curiosity would be tested in new ways. The conclusion, then, was provisional and exacting. Humanity had moved, deliberately, from reading an encoded whisper to observing a shaped presence. The probability of engineering had increased, the scale of the object compelled a rethinking of strategy and the ethical architecture of response. Open data, non-contact, multinational stewardship had been affirmed by practice. The door was not yet open in any physical sense, but it had been recognized as a portal in the cultural sense, a moment when the species must choose how to meet another artifact of endurance. Whether the encounter would become an exchange? What image does a civilization choose to show the future when it knows that the future will be many things at once, curious, cautious, and very far away? The final bulletin unfolded like a mirror held up to that question. It was not a crescendo of revelation so much as a precise, almost ritualized set of acts, a sequence of confirmations, a careful tightening of provenance chains, and then, at the last measured step, the choreography required to send, at great cost of telemetry and attention, the first clear image of the source from which the pulses had come. Across continents and under 100 institutional lights, the world watched the slow mechanics of a decision that had already been debated for weeks. The coalition's governance charter, ratified by nations and scientific bodies alike, had established rules to guard against haste, to preserve context, and to protect the possibility that the object might be an archive, a warning, or both. Those rules had shaped instrument selection and mission planning. They now shaped the final act of transmission. The reconnaissance craft, in a prescribed standoff, had been collecting high-fidelity radio maps and polarimetric modes. The technical sequence was prosaic, precise, and profoundly fragile. High-resolution imaging at the object's distance required a kind of artificial eye too vast to be carried on a single platform. The reconnaissance craft and the distributed receivers on Earth functioned together as a synthetic aperture, a stitched lens whose effective diameter only emerged when datasets were coherently aligned and phase referenced. That alignment demanded a choreography of clocks, atomic references reconciled, light-time corrections applied, Doppler compensations modeled for both the craft's trajectory and the subtle orbital. Because of the signal's prior architecture, its layered frames, its prime-like motifs, and its slow 137-second signature, the teams had a kind of shared grammar for stacking. The image synthesis itself was an act of folding time into space. Microstructure in the carrier, once coherently averaged over many frames, acted as the fine-grained paintbrush. The slow frames served as the grid that ensured every brushstroke fell into place. Error-correcting codes were not merely useful, they were the difference between a smudge and a detail. The engineers encoded redundancy on top of redundancy, parity checks across footage. Those technical choices were also ethical choices. The coalition had insisted that the first clear image be coherently reproducible from independent data products before being presented publicly in undiluted form. The reasoning was twofold. First, provenance. Every pixel had to be traceable to a raw IQ capture so that future analysts could verify and, if needed, reprocess with different priors. Second, stewardship. A single unvetted release might mislead, produce cultural hysteria, or worse, erase interpretive possibilities later revealed. Even with those constraints, human feelings threaded the operation. The languages of professional caution and public longing were different instruments in the same orchestra. In observatories and data centers, there was a charged quiet, an intensity compounded of exhaustion and reverence. Operators checked checksum signatures as if blessing a relic. Analysts annotated viewing frames with the sort of hedged language that science uses to hold revelation at bay until it can stand the weight of scrutiny, consistent with, probabilistic, subject to further calibration. The practicalities of imaging required an economy of bandwidth as stern as any austerity policy. The reconnaissance craft had stored a high-integrity copy of the raw data, but downlink windows were finite. The listening swarm offered a partial bypass. Distributed nodes could relay incremental reconstructions as they were produced, allowing parallel teams to validate results while a compressed stream of selected frames accompanied the final, full-fidelity packet. The compression algorithm selected for the public package was not lossy in the way of modern consumer codecs. It was chosen for interpretive fidelity. Behind those decisions was the persistent question that had haunted the entire enterprise: who, if anyone, would recognize the image as a message? The earlier episodes, primes, the pictogram, the 137 Helsecond rhythm, had set expectations that the sender thought in universals. The possibility that they had designed signals aware of the arithmetic of atoms and the invariance of ratios meant that the same universals should govern the visual representation. The teams therefore pursued a rendering strategy that emphasized dimensionless relationships, relative scales, integer ratios, and there was another layer of prudence too. The coalition had to decide whether the first clear image should be shown unaltered, blurred to remove extraneous detail, or withheld entirely until more confirmatory data arrived. That decision was both scientific and civic. If the image were an engineered construct, revealing it publicly would not only change human perception, but might also affect how other actors, states, corporations, or even non-scientific groups interpreted and reacted to it. The Charter's answer was to release a carefully annotated bulletin. The final minutes before transmission were full of small, technical rights that had accumulated cultural weight. Clocks across networks were synchronized to within fractions of a microsecond. Data mirrors confirmed byte-for-byte matches. The craft executed a final, planned reorientation to present its longest baseline to the listening swarm, maximizing spatial resolution. A chain of cryptographic hashes published to multiple registries locked the provenance. Each act reduced the degrees of freedom for error. Each check was a ritual of trust, an institutional promise to the unknown sender. When the first carefully compressed frames began to flow, they arrived as numbers before they resolved into forms. Analysts worked in parallel pipelines, some focusing on polarimetric interpretation, others on morphological decomposition. The early renderings were deliberately schematic, contours of intensity with overlaid error ellipses, polarization vectors drawn as arrows, and scaled insets illustrating relative sizes. Even in those cautious renderings, patterns suggested themselves. Modular repetitions recalled in physical layout what had been visible in the radiogramma of frames and primes. The modules appeared in nested scales. Across the public sphere, the release generated a chorus of reaction that was precisely the sort of social experiment the coalition had anticipated. Cultural leaders interpreted the image in mythic keys. Data scientists argued over priors in op-eds. Ethicists pressed for community deliberation about stewardship. The organizations coordinating the mission made a deliberate choice to foster deliberation over sensation. Raw data was made available, accompanying metadata rigorously documented, and community channels opened for independent analysis. The goal, among the many questions the image provoked, one was technical and immediate. Was the object an active array or a passive structure? Polarimetric maps lean toward anisotropic reflection consistent with engineered facets. Thermal mapping suggested remarkably low waste heat, inconsistent with a power-hungry industrial complex. If it was an engineered archive, its design was frugal, optimized for endurance rather than pulse power. If it was an active transmitter, its architecture was efficient, perhaps leveraging local environmental amplification to broadcast with economy. Either way, there was also a quieter, more speculative undercurrent in the analysis, the possibility that the sender had known of others long before they were seen. Universal arithmetic, slow framing, pictographic schematics were strategies that make sense if a transmitter expects its signal to live in a sea of long times and asymmetric knowledge. It is not a dramatic claim to say such features also make sense if the sender had observed electromagnetic leakage from another technological species and timed their message to arrive long after the leakage had become background noise. Radio and optical leakage from planetary societies like ours. In the final technical sweep before the bulletin closed, the transmission pipeline switched roles. The ship's telemetry, having delivered the higher fidelity packet for scientific verification, reconstituted the same data into a compressed, publicly suitable visual, a deliberate compromise between interpretive transparency and the need to avoid premature sensationalism. That visual would be the first widely disseminated image of the source, not the raw, intricate matrices kept for specialist analysis, but a clear, comprehensible representation that conveyed the object's modularity, its scale, and its anomalous geometry. The coalition framed the broadcast ended not with fanfare, but with the smallest of human acts, a promise. The ship at standoff, silent, instrumented, constrained by ethics and by flight rules, had prepared and queued the packet, compressed according to shared codes, validated by independent mirrors, and encrypted for verifiable release. The last frames went into the uplink buffer. The world read the assembled provenance, and then, in a formal voice that had been honed into policy, the bulletin announced the transmission. There was no dramatization. There was a measured communiqué that described. In the quiet aftermath of the broadcast, the greater question returned with new force: who, if anyone, was on the other side of that engineered silence? The evidence gathered: mathematical scaffolding in the signal, pictographic pointers, a slow frame near a fundamental constant, and an architected object at a quiet coordinate shifted probabilities. They suggested the hand of intentionality, and they suggested the mind that had thought about remembrance. But they did not reveal motive or identity. They did not tell whether the sender had left the marker in hope, in warning, or as a testament against oblivion. The final line of the bulletin folded the complexity into a single human cadence. We still do not know who is on the other side. That uncertainty was no failure of method, it was the honest horizon of the inquiry. At the same time, the bulletin allowed for another possibility, an implication so quiet it could be missed if one listened only for spectacle. The protocols, the universals, the economy of signal and form. All of these might mean that the sender had long anticipated listeners like us. If so, they had thought about how to be legible over deep time. They had arranged their message so that perhaps, the bulletin concluded with a voice that was neither triumphalist nor despairing but simply reflective, They had known about us for a long time. The ship prepared to transmit the first clear image. The image was simultaneously a beginning and an invitation, an artifact to be read, a presence to be stewarded, and a question sent across the dark. The world listened, translated, and promised to answer with patience. For now, the exchange was a narrow, luminous corridor of attention between the species that had made a careful pact to look and an object that had chosen silence over brute broadcast. Whether that silence had been a watchful knowing or a timeless hope, the transmission. The image was the start of a conversation measured not in hours. They had chosen to be remembered. Humanity had chosen to remember back. The ship, instruments aligned and provenance sealed, lifted the packet into the long span of signal and, in doing so, closed a chapter of hesitation and opened a chapter of guardianship. The final, inevitable truth remained. We still did not know who waited on the other side of the whisper. But perhaps the image and the long, patient measures that produced it suggested they had known about us for a long time.